Uh, Hello everyone, am I audible? Cool. Let me just share my iPad. Cool. Yeah, so first of all, how is everyone doing? How is everyone doing? Is everyone fine? Cool. Yeah, my health is better, Simple. Thanks for asking. I am doing good. I'm doing good. Thank you. Yeah, cool. Uh, so yeah, we have already had two classes of HLD, and today we are going to discuss a very important concept, which is understanding cache. So we are going to now discuss a lot about caches. Okay, and trust me, cache is something which is very powerful, and it's very important to understand. So one thing that I have seen so many people doing wrong in high level design interviews is that just they understand that yes, caches are are very helpful, but but then just by realizing that they just throw in caches everywhere. So whatever design you are doing, they will just throw in caches all around and say, I will just cache this, cache that. And that gives a very bad impression. Okay. So today's class is going to be very interesting and very important so that you understand that what should you cache and what kind of a cache should you use. Okay. And before that, we would understand that what our cache is there for. Okay. And just before starting, just a brief overview of the things that we discussed in the first two classes. Everybody in the class should be now comfortable with CAP theorem. Everybody in the class should be comfortable with the entire overview of how a request is handled, how systems are designed. All of you should be able to now appreciate what else did we cover in the first two classes? We covered CAP theorem. We covered the entire yeah, we discussed consistent hashing. So consistent hashing is very important. Okay, low sound. Okay, just a minute. We discussed stateless and stateful applications. Yes. So I hope that these things are clear to everybody. And if you guys have any doubt, I would request that you revisit the lectures and make sure that you guys keep on clarifying those things, because most likely from next class, we are going to actually start designing actual systems. We are going to take actual problems, and all the things that we have discussed till now will come in handy to design those actual problems. Okay, cool. So let's start today's class by trying to get some understanding that why caches are required. Okay, okay, let's start with an example. Let's start with an example. So all of us are interview bit users, right? All of us use interview bit. We know how things are at interview bit. So let's say you log into an interview bit page. What all things do you see? Let's say you log into your page, or let's say you log into your scalar page, you go to a dashboard. What all things do you see? Can we list those things down? So first of all, let's say you would see, yeah, you would see keep what is the streak sorry, what is the streak, present streak that you have. Then you would be seeing maybe some problems that you have solved, or maybe some assignments, some homeworks. Let's just call them problems. Then you would be maybe seeing your scores. You would be seeing a rank list. Does that make sense, people? Would you be seeing all these things? Yes. So your problem percentage, your attendance, and so on and so forth, right? But at the same time, you would also be seeing on any page that you go to some images as well, because any web page without images would look very bland, right? So you would be seeing images as well. You would be seeing videos as well, maybe recorded videos or maybe some promotional videos, etc. Right? And let's say you also see, so when you go to a problem, you also see the problem, right? You also see the problem page, right? So do you understand why I have created two different segregations here? So okay, so that nobody's confused, let me just remove this from here. And now do you see some kind of a segregation? Why I have segregated these two things? Okay, Archit, you're absolutely right. Right, makes sense, Mayur. Makes sense, Uzair. So yeah, several of you are replying by saying that some resources are static and some resources are dynamic. And another way of saying that would be that there are some resources which are common for a lot of people, and there are some resources that are individual to yourself. Does it make sense, people? Does it make sense? Does everybody in the class appreciate that these are primarily static resources, right? And these would be something, this is something which is a dynamic resource. Does that make sense to everybody in the class? Right. Now, let's look at one more thing. If we just look at the first two things in the static resource value category, would you appreciate that these are the heaviest resources that you see, right? So images would be of the order of a few MBs, right? So maybe let's say 10 MB. Videos would be of the order of a few hundred MBs, right? Let's say maybe 100 MB on average a video is of, right? Let's look at the other things that we have. Streak, these are all textual data, right? So these would be of the order of few KBs only. Does that make sense? People, does that make sense? So there is a huge difference between the amount of storage space or amount of size, the size of the resources that we are talking about. Okay. And we also appreciate the dynamic nature and the static nature of the resources. Okay. So now we have had that background, and let's just see, okay, let's just keep that background in mind, but let's just try to solve that problem without thinking about caches or without thinking about anything else. And let's see how difficult the problem may get. Okay. So let's actually solve a real life problem. So let's say let's say we are designing interview bit. Okay. We are designing interview bit. Interview bit today has 90% of our users in India, right? 90 or maybe 85% of our users today sit in India, right? But we do have users from the US. We do have users from European markets. We do have users from, let's say, Southeast Asia, right? So we have our user base is spread across continents, okay? And today the ratio may be 90 to something else, but tomorrow the ratio may change, right? So you may have a more spread out audience that we are trying to cater to, okay? And even though that audience is not still spread out, but still catering to a 10% resource is also a very, very important thing for you, right? For any company. And most likely the problem is that these markets are usually high ticket size markets. So just getting one student, let's say in the US, would be more rewarding for the company than getting 5 students in India. Just putting it out, right? So now let's say all the web pages that you serve, or all the resources that you serve to the students or the users that you have, let's assume. So do you understand that all those resources will be stored somewhere, right? All the resources that Interview Bit through its website, or let's say tomorrow we come with an app, is serving. Do you understand that all those resources will be housed somewhere, would be actually stored somewhere? That actual place where all the data is stored or all the computation is happening is actually called a data center, right? Data center. Now the data center would be physically located at some place, right? And most likely the data center of Interview Bit would be located, let's say, in India. Okay. So this is actually not the case. We actually use AWS, but let's for now understand that let's assume Interview Bit had a data center and that was located in India, because that would have been the most logical thing to do. Does it make sense, people? Data center in India. Now, for all the students who are in India, all the mentees who are in India, or all the users who are in India, whenever they request for a resource, whenever they hit anything on the website, whenever they want to get anything, they would essentially be making a call to the data center, and the request would be served through that data center back to the user. Does that make sense? Right. So this would happen over the network. Now let's say a mentee sitting in US, a user sitting in US also wants to access something. Then he or she would actually be making a call to the Indian data center, and the resource would be going back from the Indian data center to the US user. Does that make sense? And that would happen physically. Understand, that would happen physically through the optic cables. Okay. Now, this kind of a network overhead that you see when you have a data center in one continent and you have the user sitting across in totally different part of the world, you would appreciate that this entire round trip, so we just call this as a round trip time, right? So it's a round trip, right? You do a trip to fetch some request. Sorry. So you do a trip to fetch some request, and then the resource travels back to you. So you do a round trip, right? This round trip time would essentially be somewhere of the order of 200 milliseconds. Or let's say in some cases can actually go up to 1 second. Or let's maybe say 400 milliseconds. Now this round trip time becomes too large if you have users sitting in different parts, right? And similarly for Europe and so on and so forth. This is not acceptable. The user would be super pissed off if he or she is actually waiting for 200, 300 milliseconds for every resource that they are trying to get for. Indian users may be happy, but the user in the US would be very, very unhappy, right? And also, let's actually come inside India as well. India is a big country due to God's grace. So let's say somebody is sitting in Guwahati and my data center sits in Mumbai, right? There is a big difference between Guwahati and Mumbai, and still you may realize that students or mentees sitting in Guwahati would be experiencing a bit more lag, right? So this problem is not specific to InterviewBit. You would appreciate that this is a problem that is there inherently in any system where you have users across the globe. Does that make sense to everybody? Does that make sense to everybody? Right. So this is a problem that is there for every system that you have. Now, to solve this problem, what do we do? To solve this problem, maybe, so big companies came with the concept of CDNs. CDNs are essentially called as content delivery networks. Sorry. How many of you have heard about content delivery networks? So, what are content delivery networks? Before coming to that, let's actually go back to the basics that we covered. So we see that there are different kinds of resources. Some resources are dynamic, some resources are static, and more often than not, it's the static resources that are very heavy. Does that make sense? It's the static resources that are very heavy. These dynamic resources generally are very small, right? And you can fetch that data. Even if you have a big round trip time of 200 milliseconds or 400 milliseconds, you can pack all that, you can fetch that data quickly because that's a small amount of data. On the other hand, trying to actually get data from static data, big data across the world is going to be a lot more time consuming. Does that make sense? So the problem actually boils down to figuring a better way of serving these static resources. Does that make sense? Prathamesh, you are absolutely right. But we are going to discuss at a more conceptual level today. Cool. So that makes sense. Now that is where the idea of content delivery network comes. And I will tell you how it all started. So the first company, the biggest company in the domain of content delivery networks is Akamai. And that was without a doubt the first mover in the space. So Akamai or any content delivery network company came up with the idea by saying that let me invest in having my data centers all across the world. Okay. So let's say Akamai comes up and says that I am going to invest in having data centers all across the globe. And what I can do, I can go to these big internet companies who have their users across the globe, and I can tell them that, hey guys, you are storing your data in one part of the globe, right? And that's fine. But let us help you in some way. What you can do, you can store your static resources, a copy of your static resources with us. We are going to store that all across the world in our CDNs. And then whenever a user requests for that resource, rather than fetching that resource from your data center, Akamai or a CDN would serve that resource from the nearest CDN data center. Does that make sense? Does that make sense? So what's the idea behind CDNs? So CDN, a big company comes up and says that I am ready to invest in building data centers all across the globe. So what happens? In India, you have one data center of InterviewBit. So let's say data center of InterviewBit in India. And in India only, you have multiple CDNs of Akamai. Okay. So in a way, multiple data centers of Akamai. So one data center of Akamai sitting in Mumbai, one let's say sitting in Assam, one let's say sitting somewhere in North India, let's say in Punjab, and so on and so forth, right? And similarly, in the US also, Akamai is going to have several CDNs. Let's say one at the East Coast, one at the West Coast, and so on and so forth. In the Europe as well, you are also going to have CDNs of Akamai. Now, what happens? Whenever you want to serve a request, okay, rather than fetching, so let's say a US guy wants to get some resources of InterviewBit. He or she wants to view videos that we have recorded. Now, rather than fetching those videos from Indian data center, what is going to happen? The US folk is going to check the video in this data center of the Akamai or CDN sitting next to it and is going to get that resource from there. Does that make sense, people? Does that make sense? And now the resources, how do the resources actually go to the CDN? Those resources still go from your data center only. So your data center actually is the single source of truth. You are actually forwarding your data to multiple endpoints of the CDN. But that is something which is happening only once. Okay? This will happen only once. And all the, let's say, millions of requests that you are going to see from your users, those will be served from systems sitting very next to them. Okay? And the turnaround time or the network overlay time, round trip time is directly proportional to the distance between them, the physical distance. Okay? Now, Sukanya asked a question, is CDN a cache? Yes, by definition, CDN. So CDN physically would be servers, right? Physically would be servers where you are going to store data, and then you are going to have a cache on top of it, which would know, or let's say an index on top of it, which would know where is what kind of a data sitting, and you would be serving those requests. But CDN conceptually can still be called a cache, because cache by definition is something in which you add a layer of storage in between so as to enable serving your data quicker. Does that make sense? So conceptually, even though CDN consists of actual storage servers with some caches, of course, but CDNs conceptually are called as caches. How many of you understand that? Yes. Any doubt in this to anybody? Please repeat the last part. Okay. Moise says all the static resources shared across all the DCs. Okay. So a good question from Moise. Okay. Okay, Uzair, makes sense. Let me answer that as well. Okay. So let's pick up these questions one by one. Question one that I see is that are you going to store your data in all the DCs of the CDN, right? In all the DCs of the CDN. That's primarily you can do that, but you would not be doing that always, right? So let's say what actually happens. Let's say there is no user of InterviewBit in the US. Okay, nobody uses InterviewBit in the US, let's assume. Then why would I want to store my data in the US? Does that make sense? Why would I want to store my data in the US? So what actually happens is you just tell the CDN that, hey Akamai, can you just cache this data for me? I have this video. Can you just store that with you? Now what will happen? Let's actually look at the control flow of how the control flow goes. Everybody, please pay attention. This is very, very important. Okay. So you are a client, right? You are a client. You would first go to the DNS, get the IP of the service. So you would get the IP of InterviewBit. Your client will hit the IP of the load balancer of InterviewBit. Now, the load balancer is going to somehow get your data from the app servers. App servers may actually go to your storage devices, and somehow you are sending back a response from the load balancer to the clients. Okay, you are sending some response back to the clients. Now what actually happens? For those video resources or for those image resources, for those static resources, you don't send the resource as such. You send the URL of the CDN. Okay. So in your response, the response that comes back, the HTML response that comes back, you are not going to send the resource, but you are going to send a CDN URL of that resource. Does that make sense, people? Does that make sense? And now your client side code will know, okay, I requested for a resource, I did not get the resource, but I've gotten a CDN link. Okay, Manu wants me to repeat. Okay, Manu, kahan the aa raha? Sun to nahi rahe the, but still I can repeat, not an issue. So what will happen? Let's look at the entire workflow. The client will go to the DNS, get the IP of interview bit, will go to load balancer. Load balancer will get some data using the app servers and the storage, and will give you some response, right? Will give you an HTML response. Manu, does that make sense? You will get some HTML response from the load balancer. Now, for big static resources, if I interview bit am using a service of some CDN, I am not going to send those videos to the client directly myself. Instead, I will send a CDN URL of that resource. So I will send a URL. Another. What is a URL? URL is just an address on the internet. Does that make sense, Manu? URL is just an address over the internet. So what do? Rather than sending the resource, I just tell my client that, hey man, this is the link, this is the address of the resource. You can fetch that resource from there, right? Now the CDN URL, what happens now? Actually, Sukarna, just wait for a minute. Let me just tell you. So I will send a CDN URL. Now the client will make a call to the CDN URL. So how does that happen? So client will again go to the DNS, will fetch the IP of the URL of the domain, and then will send a request to the system of CDN. Now CDN, let's say there is a global endpoint of a CDN, or let's say there are multiple endpoints of a CDN. Now the CDN will realize that, okay, this is a client who is accessing me from, let's say, North Delhi. Okay, this client is trying to access this URL from North Delhi. I have just realized that what resource he or she is looking for. Somehow the CDN will ask the data center of its. CDN will ask the nearest copy that it has, will get that copy shipped from the nearest resource to the client. Does that make sense? Does that make sense? So CDN is a big guy, right? CDN is supposed to cater to requests all across the globe. Okay? CDN will figure out that, okay, this is the request that is coming from this GeoIP. What is the nearest resource that I have? And I will send my data from that location to the resource. Does that make sense to everybody? Does that make sense to everybody? Now, there can be issues where a CDN, a copy, let's say a local CDN may not actually have that resource. Okay, do you understand that? It's possible, right? A local CDN may not have that resource. So let's say interview bit, nobody was using interview bit on the west coast of the US, and tomorrow, let's say somebody used, by any chance, by random chance, somebody used interview bit. Let's not take interview bit's example. Let's take some other example. Okay, let's take any random company ABC, and now nobody was, or let's say NDTV, nobody was accessing NDTV from US West Coast. There are few people in India who would access that, but not in the US West Coast. And now let's say somebody wants to access that, and your CDN realizes, oh man, I did not have any cached resource nearer to this location. Then for the first request or a first few requests, you are going to get that resource from a farther off CDN's data center. But then, yeah, fall back to hierarchical CDNs. But then when you realize that there is sufficient traffic, it's CDN's job to ensure that it is going to copy that resource to that location as well. Does that make sense? Does that make sense, people? Does that make sense to everybody? Moez, you're absolutely right. Moez, you're absolutely right. Cool. So now are all of us on the same page that how CDNs actually work and why that's a great idea, right? Why that's a great idea, and it's only because of CDNs that today a lot of things are possible. Okay. Okay. Nikhil says the copy will be storage copy, not case copy, right? Not case copy. I did not get, Nikhil, what exactly do you mean by that? What's the difference between CDN and term case copy? What is the difference between a CDN in terms of space, RAM with respect to other servers? Okay. So CDN servers are going to be primarily are going to store data in SSDs. So that is basically beyond the scope of today's lecture. but let's try to formulate that ourselves. So CDNs would most likely in today's world would be storing data on SSDs. SSDs are slightly slower than SRAMs, which are primarily which you build caches, but can store a lot more data and also come a lot more costly. So you are going to have multiple layered architecture of CDNs as well. So just like look at this architecture, right? You're going to have a cache which you can have, let's say, via SRAM, which is just going to be an index. Let's say if somebody is looking for this resource, what is the location where I have that resource? Then you would, let's say, have a bigger cache, let's say consisting of SSDs, which would have the actual resources, the resources which are very, very highly being requested at that point in time. You're going to store that in those SSDs. And let's say at the back end, you are going to have S3 servers in which S3 basically normal DBMS dump storage boxes where you are actually going to store all the data. Does that make sense? Does that make sense? Does that make sense? Any system on the internet, any scalable system would have this hierarchy where you would be storing smaller amount of data in faster access time resources than large amount of data in slower access time responses. Does that make sense to everybody? I hope it does. Cool. Now let's look at the questions that what's the RAM size of CDNs nowadays? Okay, so that is a question that totally depends on so many factors. And frankly, I did not check that. So basically, in all the companies that I have been working at, we were actually using. So in DirectTime, we were actually using Akamai and Amazon CDN as well, which is called as Cloudflare or CloudFront, right? So in DirectTime, we are using a combination, primarily Akamai. Here at InterviewBit, we just use everything from AWS, so we use CloudFront. So what would be the RAM? That is totally, which is Sankalp, try to understand that. So that totally depends. You can estimate that, but that totally depends on how many resources you are actually being requested, and that is a thing which is slightly difficult to appreciate from where we are sitting. Okay. Cool. But yeah, we would be actually discussing in the next few classes, we would be actually discussing that what kinds of machines do we have in the world today, and what kind of resource, what kind of storage do you have, what kind of speeds do you have. We are going to discuss that in tomorrow or maybe day after tomorrow's class. Sankalp, then maybe we'll be better able to estimate it. Okay, cool. Let me see what all questions did I leave in between. Prathamesh asks, so CDN does not actually have the resources, but a nearer pointer that can reduce the latency. No, Prathamesh, CDN actually has the resources, right? CDN may not have the resource all across the globe at any given point in time, but CDN's responsibility. So let's say I am a user of CDN, I am running a big business, and I go to CDN and say, hey man, I want your services. CDN will most likely enter into a contract with me by saying that for 99% of your requests, I am going to promise you access time of, let's say, 10 milliseconds or 10 seconds. Does that make sense, people? So CDN would promise you by saying that, let's say, 95% of your requests are going to be served within this amount of time, 99% of your requests are going to be served within this amount of time, 90% of your requests are going to be served within this amount of time, and that's now CDN's responsibility. That how many copies does it want to store, what kind of a cache does it want to store, where all does it want to store the data. That's now CDN's responsibility. Does that make sense to everybody? So we are actually going into much deeper details, but yeah, these are interesting things and no harm in knowing those, right? So Prathamesh, I answered your question. Let me see what other questions are there. So here is saying if the nearest data CDN is not present, then it will store in the nearest only at. So Sohail, I did not get your question. So Sohail, if the data is not present in the nearest CDN endpoint, it will fetch from somewhere else. But if it starts seeing a lot of requests coming from that source only, it will also store a copy there. I hope it makes sense to Sohail. Manish says, so is it double round trip? First load balancer, return CDN URL, CDN figures out. Okay. Makes sense. So CDN would also have, let's say CDN would also have multiple entries on the DNS server, right? CDN would not have a single load balancer, would have different entries, right? And then it's only the first request that actually comes to a bad, that may come to a bad CDN. Understand? Let's understand that. That's also something that I was planning to cover in some other class, but let's just discuss that. So what happens? Let's say CDNs are present all across the globe. I get one random IP from the DNS. Let's assume the DNS gives me a random IP. We discussed that DNS generally sorts IPs randomly. Do you guys remember that? Sorts IPs randomly, give it to the client. The client will go with the waterfall model, try with the first thing and see if it can hit it, right? So let's say you are very, very unlucky and you actually reach, you are sitting in India. The entire problem was that the data center was in the US and you were frustrated with the company ki, man, this site takes a lot of time to load. And now the site owner contacted a CDN and now you are hitting a CDN, but unfortunately, just because you are very, very unlucky, you actually end up going to the CDN which is sitting in the US only, right? But try to understand. That is something which will only happen for the first request, right? So I send a request to the CDN sitting in the US. They are going to reply back to me that, hey man, from your next request onwards, rather than coming to this IP, you can prefer going to that IP. They will tell me an IP which is very, very closer to me. And from the second request onwards, I am going to fetch every data from the closer IP. Does that make sense? Does that make sense? And spending some time on the first request is no big deal. You would hardly even notice that. Okay, I hope things are clear. Now let me see what all questions do we have. Sorry. Uzair says, so if some person from India uses a VPN that connects to USA server and from the server he calls into it, Uzair, that's true. That's true, Uzair. But let's not go into VPNs for this. So yeah, that's actually true. That's actually true. Won't there be any security issues? Okay, let's actually discuss security issues as well. That's again a good question. Then Nikhil says, should the CDN URLs itself be? Nikhil, I hope your question has been answered now. Cool. So we have discussed these things. Let me just figure out what should be the best way of figuring, what should be the next thing that we discuss. Should we discuss the security? Maybe let's just wait. Okay, let me just give you one example first of all. Okay, let me just give you one example so that you guys, yeah, Sankalp your apps. You are absolutely on the right track. Let me just give you the answer to that. So let me just open Facebook. Are you guys able to see my screen? No, you would not be. You are not, right? Can you show it in a browser? Okay, I can do that. I can do that. Without a doubt, I can do that. Let me just do it. Let me open any image on Facebook. So I will try to share my screen. Can you guys see my screen? Can you guys see the screen? Can you guys see my screen? Yes, you can. Cool. So this is an image which we posted on InterviewBit's Facebook page, and the URL that you see here is this, right? This is the URL that you see. Does that make sense, everybody? The URL that you see is this. So let's say this is the URL of the post, right? But the URL of the image would not be, so look at the URL. Look at the URL. What is the IP? What is the domain of the URL? The domain is facebook.com. Does that make sense? Then you have a route and then you have the resource. Does that make sense? So how URLs work, you have a domain, you have a route, and then you get to a resource, right? So this is a resource that you have. But the image that you have would not be stored at Facebook's, would be stored at Facebook server, but you would not be getting that image from the Facebook server. It's okay. Just because I mentioned that, let me clarify one thing. I have seen several students misjudging that thing. Never think that this image would not be stored at Facebook's DC also. The image would always be stored at Facebook as well. Facebook would not say, Acha, I will only store the images on CDNs and I cannot worry about it now. Does that make sense? Can InterviewBit tomorrow afford to say that all my videos are stored and on CloudFront only? I do not care to have those videos with me. No, I cannot do that, right? CloudFront or any CDN would just have a copy of that resource. The ultimate source of truth still happens to be with me. Okay, so yes, the ultimate source of truth of this image still happens to be with Facebook, but the URL from where I am getting this image would not be from Facebook's data center. Okay, cool. So now what next? So originally, let's say a few years ago, Facebook used to use Akamai as far as I know. But now, from what I understand, they have actually moved to they have actually moved to Facebook CDN only. So now they do not use Akamai, they have built their own Facebook CDN. Yeah. So this is the link of the image. So now you see where is this resource coming from. You would see that this is resources coming from a domain called as FB CDN. And FB CDN is nothing but a CDN that Facebook only owns, and it's a CDN. Does that make sense? So just like Akamai, Facebook has their own CDN because that makes total sense for them. They are a big internet giant. They have their customers all across the globe. They are going to serve data all across the globe. So it's better, why not build an in-house CDN, right? Right. So a few years ago, Nishant, you're absolutely right. From what I know, they were using Akamai. 2012 or 13, I do not know the exact time when they switched, but yes, now they are using Facebook CDN. So you guys now see that this is the resource image. So I can open that on my incognito as well. And I can see that image. Does that make sense? Does that make sense, everybody? Now I have a CDN URL and I can get that image from the CDN. Now let's try to, okay. So do you guys want to move away from CDNs? Should we move to the next topic, or I have a few more interesting things to discuss? If we want, we can discuss that. So they build their own DCs everywhere. Yeah, they did. Okay. So let's discuss a few more things, right? Right. Cool. So now that also actually, if we want to update the CDN, Nikhil, that I'm totally going to discuss how to update images or how to update CDN resources. That is a big problem of caches, which is called as cache invalidation. And I'm going to discuss that very deeply today in today's class. Okay, that's a big problem, cache invalidation. We'll discuss that. Before that, I was saying, okay, so let's say now I have a CDN URL. Okay, now I have a CDN URL, and let's say previously Facebook used to store images on Akamai. Okay, use Akamai as a CDN. Okay, now if I start sending, if let's say I want to share an image with you guys, one option that I have is I share the Facebook's URL. Does that make sense? One option that I have is I share this URL with you that, hey man, this is the image. I find it very interesting. Maybe you can also have a look at it. Okay. Now, if I share this image, Facebook is getting profited. Does that make sense? Facebook now knows that Nikhil sitting in his home in Delhi is seeing this image, right? And maybe Facebook can now serve ads to you. Facebook knows that how interesting this post is, how viral this post is going. Facebook has all that data. But let's say I am a weirdo and rather than sharing this link, I start sharing this link with you guys and tell you the CDN link, right? And now this was the Akamai CDN. Facebook would lose out on the control of figuring out that who is looking at what information and how many times a post is being viewed. Does that make sense? That information now rests with Akamai or the CDN that you're using. CDNs do actually provide that service of letting you know, of setting some different, let's say, what do we call params, and figuring out that, okay, somebody sitting in Delhi who is a male who is of age between 25 to 30 is looking at this image. Okay, so CDNs can collect that data for you, and maybe you can pay the CDN and ask for that data, but then that would be just like buying your data yourself, right? So why not actually come up with your own CDN? So that may be one big driving force for why Facebook came up with the CDN. But I'm not saying that's the only reason. There are several other reasons. You can, with scale, you can optimize your costs. You have a lot more control, and you also have the control over your data. Does that make sense, guys? Same with the case of YouTube. So YouTube would also, so let's look at any resource on the internet which deals with a lot more storage, right? So let's say YouTube, or let's say Hotstar serving IPL final matches to millions of people is not possible from their data centers. Does that make sense? No matter how many data centers you open, no matter how much resource do you invest, you would not be able to serve that kind of scale with your data center. All these things are possible only via CDNs. Does that make sense to all of you? So now, with one thing that you should know, in any problem, in any interview in which you see a lot of scale of the same resource being used by so many people across the world, you should know that you should talk about CDNs, and do not talk about CDNs just like any other random person would talk about. Understand all the things that we discussed today and utilize those things to make a very, very strong argument of what kind of a CDN, how would you want to store it, how would the control flow look like, so that the interviewer gets impressed and understand that yes, this person knows about CDNs, and only then he or she is claiming to use CDNs. Does that make sense? Cool. Cool. if the scope is only within one country, Nikhil, most likely then also you would be using CDNs, because a country can also be very big in a geographical manner, and that's why you would want to have resources sitting in different parts of the country. Okay, cool. Yeah, for India as well, right, Nikhil? For yes. Now there was a question of security, right? Of security. So one very basic thing that CDNs do to ensure security or privacy is that the CDN URLs are not at all guessable. Does that make sense? CDN URLs are not guessable. So Nikhil, Manu, or Uzair or Moez would not have been able to guess this URL no matter what they do, right? So can you guess this URL and say, okay, maybe one image of Facebook would be sitting on this URL? No, it's impossible to guess, right? So they make it very, very hard to guess any URL. You cannot get the URL unless and until Facebook tells your client, hey man, this is the URL. Does that make sense, people? Does that make sense? Right. So one very basic thing that CDNs do is to make sure that the URLs are not guessable. Second thing, which was not possible several years ago, but is possible today, very much possible today, is that CDNs can also do authentications. So CDNs, with the help of your basic data center together, can help you do authentication. I think we can leave out on discussing that how that is happening, because that will totally be out of the scope. But yes, you can understand there are several ways. I will just give you brief overviews. So several ways, right? So maybe the DC, the actual DC in which you actually made the first request, sends to your client the CDN URL, and with that also sends some kind of a key which is not going to be accessible to anybody else, right? A key with which the CDN can identify that yes, this is the right user accessing for the right resource. Does that make sense? So with the help of the actual data center, actual system, you can token kind of thing, right? Exactly. Session IDs, token IDs, using keys, these kind of things, you can actually ensure that there is some kind of authentication at CDN level as well. So that allows people, so let's say Hotstar, to ensure that it did not happen that one guy purchased my license and I sent him the CDN URL, and now that guy shared the CDN URL with the world, and now the entire world is like getting the access from the CDN, right? So Hotstar will be able to ensure that that is not the thing, because you can actually have authentication for CDNs as well. CDN provides a URL. A question. CDN provides a URL of resource stored. So Sankalp, CDN would provide a URL. CDN would provide a URL. There would be one URL only, right? There would be one URL only. But when you hit the first time, when you hit any CDN's endpoint, CDN would tell you, hey man, from the next time onwards, use this route, but use this different IP. And that is the IP that is sitting very next to you. Does that make sense, Sankalp? Moez, you're right. This did happen for a brief time. Is CDN a cache? Yes, Manu. CDN is just a form of a cache. Okay, cool. I think we can move ahead because I see two people have left the class, which makes me very sad. So if you want to leave the class, please just let me know that there is something urgent for why you are wanting to leave the class in between. Okay, cool. Let's actually move ahead. Uh, any other doubt about CDNs? Yeah, we did missed out on cache invalidation. Okay, so cache invalidation. How to do cache invalidation? That's a big thing in caches. People, are you guys with me? Is everybody with me? Yes. So how to ensure that you do cache invalidations? So this is not a problem which is specific to CDNs, right? Okay, first of all, what is the problem? The problem is that you have now you do not have your resource only at your DC, but you have distributed that resource to the world, right? You have distributed that resource to a CDN, and now CDN has stored copies of that resource all across the world. Does that make sense? Does that make sense? So now CDN has stored copies of that resource all across the world. Now let's say tomorrow, I realize that some naughty guy uploaded a naughty image on Facebook, which should not have been there, right? And I have now somehow, because that the algorithm that I have at my end was not online, but that was an algorithm which was offline. So what is online, what is offline? We will be discussing that in the next classes. But just for now, understand the words. Online means that you are doing some processing on the go. Offline means that you are maybe storing that thing in a queue and taking things one by one from the queue and then processing them one by one. Does that make sense? So let's assume the algorithm that Facebook or YouTube or any such social media website has is an offline algorithm in which they keep on checking images at their own leisurely time and see if that conforms to the community guidelines or not. Does that make sense, people? But now, just because that is the offline process, and in the meanwhile, I have distributed that image to the world, and now, even if I remove that image from my end, that will take some time to be reflected all across the world. Does that make sense? Because the images are present all across the world now, right? And people can still access them. So for that, you understand that the data that you are storing in caches may become outdated. That is not a problem only with CDNs, but with any cache. Understand, any cache in which you store a copy in a cache, the data may now no longer be relevant, may be outdated, right? So it's very important to ensure that you invalidate that data. There are so many different ways of invalidating that data. We will be discussing that throughout the course, the classes that we have, that how to invalidate caches. I will tell you one way, one very simple way is time to live. That is, whenever you send a resource to the CDN, you tell it to them that, hey man, this resource will only live for, let's say, 4 hours. And if somebody wants to access this resource after 4 hours, you better check with me again. You better get the resource again from me and only then serve it. Does it make sense, people? So there is a very simple way of cache invalidation, which is time to live. Does everybody in the class understand that? Right. Another simple way would be another simple way would be that when you are actually sending your HTML to the client and you are sending a resource, a URL of the cache of the CDN, you can now start sending a different URL, right? Or you can start sending the same URL, but with some new tag which tells that this URL or this resource was last modified at this time. Does that make sense? In the response header, you tell them, yeah, Nishant, you're absolutely right. You tell them that, hey man, this is the resource that I want you to access, but I am telling you one more piece of information, that this resource was last updated at this time. Does that make sense? And now when you hit that URL to the CDN will realize that, okay, this guy is looking for a resource, but the last updated time that this guy is asking is a time for which I do not have the data. So I will not serve the old data and instead get the new data from the DC, original DC, and then serve it. Does it make sense to all of you? So you can just call it versioning, you can just call it last modified. That is one approach. The other approach is time to live. We'll be discussing some other approaches as well throughout the course. Okay. Let me give you one example of this. Okay. Let me give you one example that I can think right away from InterviewBits case. So what do? When we want to refer you guys to companies, what do? We have to share your resumes to companies, or we have to share your resumes with recruiters, right? We cannot afford to share your original, or let's say not only referring you, but let's say InterviewBit as a organization which was a referral organization, or a organization which used to get people placed. Now we cannot afford to share the URLs, or share the resources, the resumes with everybody around, right? So let's say if I share the resumes of 5 people with a recruiter that I know for a job opening at media.net, I would not want that recruiter to share those 5 resources with everybody else in his or her group, and now they can directly contact the students and get them placed. Does that make some sense? So do you understand that there may be a business need of ensuring that your data does not get dissipated, right? You have control over your data. For that, what do? We give them a URL of CloudFront, let's assume, and we set a very short TTL. We say that this URL is only going to last, let's say, for 4 hours. Okay, so even if you are sharing that URL, you would not be able to access it beyond 4 hours. Okay, now you would say you can download it, you can take images, and so on and so forth. Of course, you can do that, but at least you're making it a bit more difficult for people to share your resources amongst themselves. Does that make sense? Cool. Right, answer. That's right. Let's now move ahead. So the example that I wanted to give was resumes on InterviewBit. Okay. Is CDN crystal clear to everybody in the class? Is there any doubt about CDNs now? I hope not, right? Okay. Let me share my screen. Let me share my iPad again with you guys. Okay. Just a minute. Yes, Nikhil, TTL invalidations would be used in other caches as well. Nothing specific with CDNs. Okay. Now, we have discussed one kinds of caches. Deepika has a question. What is the usual algorithm used for removing data from CDN, like old videos? Is the contract based on the amount of space used? Okay. Right. So the contract that would be there with CDNs would be based on 2 things. One would be the frequency with which you are hitting, that is the number of requests that you're getting, and the amount of data that you're transferring, or the amount of data that you're storing. So yes, you would actually want to tell the CDN that, hey man, I do not require that data anymore. You can remove that. So that would be very simple thing to do by using versionings. So you can just tell, hey man, I'm only going to pay you for the latest version. Whatever is the old version, it's your duty to delete it from your end. So that's why the very simple thing. Or TTL, that I will tell you that this resource only lives for 4 hours, and I'm only going to pay you for 4 hours. Does that make sense, Deepika? Cool. So now let's move ahead. So we have discussed one form of caches, which is CDNs. Now let's discuss another form of caches, which is the client-side cache. Cool. What is the client-side cache? Okay. So let's take an example. What example do we take? So first of all, as Manish rightly points out, client-side cache is the cache which you are storing at the local storage of your client. Okay, what can be your client? Your client can be a browser. So you may be accessing your resource from a browser. Your client can be a desktop app. Your client can be a mobile app. Does that make sense? Your clients can be a browser, a desktop app, a mobile app, right? So whatever things you store at the client side, that is called as a client side cache. Does that make sense theoretically? Does that make sense, folks? Does that make sense theoretically? It does, right? Good. Now let's try to see some use cases of where you would actually want to do something like this. Okay, cool. So let's take InterviewBit's example again. So let's say by design, we have our batch rank lists, which are updated only once every 24 hours. Let's assume that. Okay, so let's assume we update our batches rank list only once every 24 hours. Now, This is the client. The client goes to the load balancer. Load balancer will go to the app servers. App servers would go to the storages. And let's say you access your rank list away. Or let's maybe take a better example. Let's not go with rank lists. Let's say you have stored your image on interview bid. Okay. So you want to see yourself whenever you are on the dashboard, you want to see that, hey man, that look, how good do I look? And I want to see that image. And let's say you have that image, right? Now, getting that image, same image again and again from the load balancer, that is from this service, or from even the CDN would not make much sense. Because that is something that you can store at your client only. Does it make sense? You can store that information at your client itself. Why would you want to get that again and again from a CDN or from a load balancer, right? So when you start storing resources at the client itself, the local storage, what it does, it actually reduces or finishes the latency, and it seems as if the perceived latency is very, very less. What is perceived latency? Latency actually means the time it takes to fetch a resource and to present it. Perceived latency generally means here, what is the end user's idea of the latency? How much latency is the end user perceiving? So when you actually store information at the client side itself, the perceived latency becomes very, very less. Does that make sense? Does that make sense? The user thinks, acha yaar, I got this video this quickly. They must be doing something which is quite crazy at their end, right? But they did not do anything. They stored at your end only, and you are accessing that from your only. How is offline web browsing works? Right, Vaishali. So when you are actually browsing, so let's not call it browsing, but whenever you're accessing things that you have already cached at your end, you would not want to hit any request, make any request, and you can see that even if you are offline. Does that make sense? Right. So Archit says, video also. Yes, you would want to cache some video at your end itself. So Kanya, you're absolutely right. So let's for example say that you want to view a recorded lecture. Okay, Archit, you want to view a recorded lecture, and you get that recorded lecture. So that recorded lecture is coming to you, right? But maybe you stop that in between, but you are still getting that lecture, right? And that lecture now gets stored at your local storage, so that whenever you play, you need not fetch for that resource bits again and again. Okay, cool. Now let's take a very, very good example, which I just remember, which would explain the client side cache very, very nicely. There must be a size limit. Of course, Vaishali, every process that you run has some limits on the resources that it can take. And now the client side code that you write, the JavaScript code that you write, would actually have to deal that how would you actually manage the caches, what you would want to expire, when would you want to expire, what would you want to store, and so on and so forth. So every process that runs with some fixed resources. You cannot imagine finite resources. Does that make sense, Vaishali? Right. So Sankalp is asking what app caches a message on our site. So yeah, the example that I recall is Tinder. Okay. So let's say Sankalp is using Tinder, and he has actually stored. He wants to maximize his chances, and he has now clicked, let's say 12 or 15 photos, and yes, right. And he also keeps on looking at his photos every day to figure out that, okay, how am I looking at it? Okay. Now, this is a perfect example of why the Tinder app would want to store that 12 images at your mobile itself. Does that make sense? So no matter how many times you open the app, so you open the app today, you open the app 7 days down the line, you open that app next hour, whatever you do, you are going to actually fetch that images, or let's say your profile data, the basic profile data, from your local storage only. And you need not actually fetch it again from the database. Does that make sense to all of you? What if we log out and log in again? So Sukanya, you would realize that apps, the mobile apps actually have that data stored in your device. So even if you log out of your app, you come back, you can again access that image. So do you guys see that? So what actually happens? So let's look at the example of WhatsApp, right? Let's look at the example of WhatsApp. So whenever you receive images on WhatsApp, you can always see those images being stored on your phone itself, right? So even if you're not accessing WhatsApp, you can just go to your phone's device and just scroll through those images. Does that make sense, everybody? But now there are things, there are apps which would want to protect you from doing that, which would want you to not be allowed to do that. So what will they do? They will store an encrypted copy at your device, and that thing can only be decrypted from the app. Does that make sense? So let's say Tinder sent you the image of your prospective match, and now Tinder has actually cached that at your end itself. Okay. But now I'm not saying that Tinder would cache it. We would discuss that going forward if we design Tinder, that does it make sense to cache those images or not. But let's say Tinder decides to cache those images at your client side, but still Tinder would not want you to be allowed to actually look at those resources without Tinder app's permission. Does that make sense? So what if that girl or that guy unmatches you going forward? So the Tinder would want your access to be stopped of those images, right? So what they would do, they would store those images in your phone in an encrypted format, and now you can only decrypt it using your app. Does it make sense? Cool. I hope it makes sense. Now let's discuss again the problem of invalidation comes here. Does that make sense? Vijay, you're absolutely right. Amazon Prime का बिल्कुल सही example है. Do you guys understand that there is again a problem of cache invalidation here? Does that make sense? Do you understand that there is a problem of cache invalidation here as well? What if, so who was the person who we used as an example? Sankalp, right? So let's say Sankalp realizes that 3 of his images were not that good, and those images were reducing his chances of whatever objective function he had, right? So if he realizes that those 3 images are reducing his chances, he would want to remove those images, right? And if I want to remove those images, then I let's say I am using Tinder from 2 mobile applications. Okay, from 2 mobiles. I'm using Tinder from 2 mobiles. So now I sent a request from 1 mobile to delete those images. Tinder would remove those images from its data center and would also remove from the local storage of that device. Does that make sense? Does that make sense? But now, if Sankalp accesses his account from some other app, from some other device that he had installed Tinder on, he would see those images again. Does that make sense? And he would get very angry. He would say that that Tinder is conspiring to reduce his chances, and he would not be very happy with that, right? So now, how to handle those cases? Again, a problem of cache invalidation comes up, and a very simple way of doing this is to actually not exchange the resources, but just exchange a hash. Okay, so what will happen? Before showing those images to Sankalp, Tinder's app will send a request to Tinder's DC and say that, hey man, I have these images, these resources, and this is the hash value of these resources. Can you just confirm if the hash that you have is the same? Or let's assume it's the other way around. The Tinder's application, mobile application, will send a request to Tinder's data center and say, man, can you send me the hash again? Tinder's data center will send the hash again. Now the app will check if the hash that it has retrieved is same as the hash that it had. And if it was not the same, it will realize that there are some changes that were made and will request the new resources. Does that make sense to you guys? So rather than transferring the entire data, you just transfer some metadata, which is very small, to figure out if the resources are up to date or not. Does that make sense? Does that tell us the third way of ensuring cache invalidation, which is metadata exchange, or let's call it hash exchange? Guys, do you understand it? Do you not understand it? Are you guys not able to see the screen? Are you guys not able to see the screen? It seems the screen is stuck. Is the screen stuck? Okay, let me just share that again. Yeah, can you see the screen now? Okay, cool. So let me see what questions did I miss in between. What is the basis that the data will be stored in local storage? Is it frequency? Priyanka, that's a problem of cache uh, of that is also called as cache invalidation if I'm not wrong. But that's the problem of how to actually how to decide what to store in caches. Wait for some time. We will be discussing several approaches of doing that, Priyanka. Okay. Okay, so people are saying, can you actually write down the other invalidation strategies as well? Okay, so till this point in time, we have discussed 3 cache invalidation strategies. Okay, one would be that you can actually, one would be that you can actually have a TTL, that your resource has a time to live. Does that make sense? Second would be that you can, what was the second thing that we discussed? TTL, and second thing would be that you can change. Yes, you can do versioning, right? You can do versioning. You can do versioning, or you can change the URL that you are sending, right? Third would be, so this is basically a push mechanism. That is, your data center is telling you that, hey man, something has changed, please update it. Now, a very similar thing of the second approach, but a pull mechanism, is you can actually do metadata exchange or hash exchange. Does that make sense? That your device can actually check whether the hash that it has is the same as the hash that is present there or not, and you can do it. Does it make sense? Do you guys remember push and pull? We discussed push and pull in the last class, I suppose. Yes, so that's a concept of design, and that would be, you will be seeing that again and again in different locations. Just hold on for a bit. Just hold on for a bit. Are you guys able to see my screen? Okay. What screen are you talking about? Can you guys see my screen of iPad, or can you see my desktop as well? Can you see my browser? No. Okay. Cool. Cool. So yeah. Okay. We have discussed about cache invalidation strategies. We were discussing at this point in time about client-side caches, right? We were discussing about client-side caches. What else do we want to discuss? We discussed client-side caches properly, right? We discussed what you can store there. Right. Any doubt about client-side caches? let's actually take one more example. Okay, let's actually take one more example, and that is an example which is very, very interesting, and I'm pretty sure that you would actually realize that yes, you have noticed that yourself happening several times. So let's say you are designing a Google search. Okay, you are searching something on Google and you want to design a Google search, and specifically you want to design at this point in time the type ahead of Google search. What is type ahead? Type ahead is actually that, let's say you go to google.com and then you enter, let's say, Tarun MA. So most likely it will come up with some suggestions, and it would be, let's say, Tarun Makhija, Tarun Malhotra, Tarun, and so on and so forth, right? So you would get some suggestions. So this is called a search type ahead. That is, you are searching something, you are just typing it, and the service is only helping you with suggestions. Does that make sense? Does the problem make sense? Right, the problem makes sense. Now let's say, let's not go into how this will be designed internally. We'll be discussing that, let's say, in tomorrow's class or day after. This is a good problem. I would want to discuss that Wow. But let's now look only from the perspective of client side caching. Okay. Let's only look from the perspective of client. So let's say I am a client. I want to search something on Google, and let's say I write MIC. Okay. And what will happen? Google will hit a request to Google search type ahead and tell them that, hey guy, hey man, there is a person who is a user ID this, मतलब उसका मतलब his name is Tarun, and you know all the things about him. You know what he searches, what he is interested in, and he is trying to look something called as MIC. Can you figure out what exactly he means? So now Google, based on my history, based on let's say so many things, based on what is trending in the world right now, and so many things, would come back and say, tell to my client that yes, I know this guy and I know what is happening in the world today. So this guy might actually be searching for a microphone, might actually be searching for Michael Jordan, might actually be searching for Michelle Obama, or let's say might actually be searching for Microsoft. Does that make sense? Right. So Sukanya says, I may be searching for mice. I am not somebody who would be searching for mice. Not interested. Mickey Mouse. Okay. Right. Cool. So let's say these are the options that Google feels that I would be interested in. And these are the options that I have received. So now what will happen? Let's say in the meanwhile, I've got those options. And now what did I do? I actually typed a H as well, right? Abhi previously I only typed MIC, I got these responses and Google is showing me those responses. Now I actually type MICH, right? In the meanwhile, Google will actually make a request, a new request, and tell कि bhai now he's searching for MICH. Pata karo what is cooking, right? What is cooking? Google in the meanwhile will reply back with some answers. In the meanwhile, just to reduce your perceived latency, your client will actually utilize the client side cache and will filter the responses from here and see the microphone still is valid because MICH is matching. Michael Jordan is still valid. Michelle Obama is still valid. Microsoft ko hata do, mice ko hata do, so that the user feels, yeah, Google is very fast. I just typed H and I'm seeing these three options. But Google did not actually did a round trip down in the trip in the meanwhile. Google's answer would, let's say, come after a few milliseconds. And now what will Google do? Google will see, the client will see that, okay, Google has came back with 10 responses, which start with MICH. I am intelligent. I've already shown these three answers. I will select the remaining 7 and populate them later. Have you seen that happening in Google search sometime? That when you type something, some of the responses come very, very quickly. Some of the other responses take a bit more time to come. Does it make sense? Do you now appreciate that how that actually is happening behind the scenes? And does that make you any happy? That makes me a lot happy. Does that make you guys happy? Yes, I hope it makes you happy, right? So you now understand that how you now understand that how there are systems to reduce the perceived latency of the user. The user feels as if the latency is low. The latency is still high. Abhi bhi this service will still take, let's say, 200 milliseconds or 100 milliseconds to reply back. But but the user will feel कि यार बहुत जल्दी आ गया. And till the time the user will read these three options, the remaining 7 will be populated. Okay, cool. Yeah, just try with the same. Okay, cool. So we have understood it, and we now understand that how client-side caching. So whenever you want to reduce the perceived latency. So remember this forever. Remember this line that I'm going to say forever. Whenever you want to reduce the perceived latency, always think about client-side caches. And I'm pretty sure for some of you, this may actually turn out to be the turning point in an interview, and the interviewer will feel that yes, this guy knows what he or this person knows what he or she is talking about. Cool. So we now understand client-side caches. Can we move ahead? Can we move ahead, folks? Cool. So we have discussed till this point in time 2 kinds of caches. We have discussed CDNs, which is one form of cache. We have now discussed client-side caches. Let's now discuss the third type of caches, which is called as app server caches. Okay. Cool. Okay. Where does cookies fall into? You cookies are actually stored to maintain your sessions, right? That is also a kind of a cache. You can also very well call it a component of client side cache. So you are storing something on the client side, and you can totally call it to be one kind of client side cache. Does that make sense, Jose? Let's now move ahead in. Yes, Sukanya. Browser has local storage, session storage. Browser has that. This is client side data. Absolutely. Whatever is stored on your browser, Sukanya, that's your client, right? Server has nothing to do. The system has nothing to do with it. Your client has stored it. It's called as client side storage. Okay. This entire thing, which includes cookies, caches, and all these things, are called as client side optimizations. So maybe if we have time, we can discuss other possible client side optimizations. Or maybe if you take front end full stack course, then maybe the person who would be teaching you then would be discussing about client side optimizations. This is a very, very interesting thing, that how you can optimize at the client side without involving the server. Okay, cool. Let's now move ahead and discuss app server caches. Do not confuse this with the mobile app. This has nothing to do with the client side caches. This actually means the app servers that you have. So this is your client. This is your load balancer. Your DNS sits somewhere here. Your CDN sits somewhere here. Then you have your app servers. Then you have your storage layer. The kind of cache that I am talking about now is called as app server cache. That is, you have now maintained a cache on all of these app servers. Does that make sense, guys? So now the cache that I'm talking about is this, that app server cache. Do you appreciate that this is a perfectly valid cache to have? That the boxes that you have, you can just use a part of the memory to have a cache there, right? The other option can be that you do not use the boxes memory, but use a one-to-one mapping with an external device, let's say external SSD or something, in which you maintain a cache. But that is a difference that you should not worry about. Let's just assume that you have the cache stored in the box itself. Does that make sense? So this is the kind of app level caching that we are talking about. Let me give you an example. Let me give you an example of where this is going to come in handy. Are you guys with me? Any doubt till this point in time? No, right? Cool. Right. So now, let's say you are again, let's take interview bits example only. Now, the client logs in. The client has been logged in. Aswar, you are right. Aswar, you are absolutely right. That would be an example of app server cache. That's absolutely right. Cool. So now, right. So let's say interview bit. You are accessing interview bit and you are making some requests. So let's say you want to access that what all problems did you manage to solve in the DP lecture that I took, let's say 2 months ago. Now, what will you do? You will send a request to the load balancer, and you will be now assume that these requests are stateful. Is it good to assume that these requests are going to be stateful? That is, it matters that who is accessing that and at what time is accessing that. So these are stateful requests, right? And do you guys remember that we discussed that for handling stateful requests, having a consistent hashing in place is a good strategy. That is, you now have a dedicated box for tackling requests for a dedicated person. Does it make sense? So now you would know, using this consistent hashing, that if the user ID is 107, then this is the box which should be having that data. Does that make sense? Now let's say there is some data that I get I use all the time, right? So the data can be something like that. Let's say what is my rank list, or let's say data like how many problems have I solved, or let's say data like uh, what is my attendance, right? What is my attendance? What is my streak, and so on and so forth. How are my referrals going? All these things. So you would be wanting to look at all these things, right? So now it would be advisable to store some cache some of that data in that app server itself. Does it make sense? Because rather than going for every request to the storage layer and having one extra hop and having devoting more time on the network for that one extra hop, it's better that you can store some of the frequently used data in the server itself. Can we do that? And you can potentially even do different things. So you can say that, let's say this server actually deals with user ID 107, 108, 109, let's say 701, 720, 727, and so on and so forth. Let's say now I can know that there is a user 109 who does not access anything. ठीक है, वो कुछ करता ही नहीं है यार आके, ठीक है. Why would I want to store his data here, right? Why would I want to store his data in my app server? Does that make sense? So I can potentially have an app server cache which is shared amongst all these users, and I can just have a least recently used or most frequently used or any such of these replacement strategies and have the data stored here. Does it make sense? It will now allow me to store very little data for 109 because 109 does not come. But let's say 107 happens to a very active user, and I will be allowed to now store much more data about 107. Does that make sense? That's how you are utilizing your resources in a better format. That the person who is very active, you store more data about him in the cache. The person who is very less active, do not store enough data about them in the cache. Does that make sense to you guys? Does that make sense to you guys? No. So that's why we would want to have app server caches, and that should be great. Now there is one. So do you have any questions? Do you guys have any questions? Okay. Is there a problem of cache invalidation here? Of course, Suhail. The problem of cache invalidation happens everywhere. Do you understand that? Anywhere. What is cache? What is cache? Understand. A cache is just you are maintaining a copy of a resource. The resource is going to be pure, but the copies can become old, can become impure, and so on and so forth. Does that make sense, Sohail? And does that make sense to everybody else? Never ever think that cache happens to be your ultimate source of truth. Cache just happens to be a copy, and that copy can totally be out of sync, or you can actually want to stop serving that copy due to any XYZ. So cache invalidation problem always exists. Okay. So now Manish says, Redis memcache, cache. What is cache? How come I did not? Okay, cool. Okay, cool. Right. So we are going to discuss memcache. We are going to discuss Redis, not today, but let's say in some further classes. Okay. So we are going to discuss these things in a very detailed manner. If you want me to discuss anything else as well, feel free. The concept remains the same. So let me tell you how do I plan the high level design lectures, right? So for the first few classes, we are going to discuss everything about the basics, right? We are going to discuss the basic building blocks, and then we are going to start with a few questions, with a few real life systems, and we'll see that how we can use the basic building blocks to design those systems. And then at the end, we can actually look at some out of the box solutions that we were using in our design abhi, but how are those solutions working using the same high level design principles? We're going to discuss that at the end of this course. Does that make sense? So this is how we are going to have our Sukanya says how many basic building blocks are remaining. So Sukanya, I hope you're not getting bored, but okay. So if you want to ask how many resources are remaining basic building blocks, so we are going to discuss this today. Tomorrow we are going to do a question most likely, and then we are going to discuss storage one day, and then we are going to discuss more questions. Okay. So that's great to know, Sukanya, that you are not bored. Right. Right. Makes sense. Makes sense. Now there is a good question from Sankalp. The question is that when should be this app server cache be preferred over, let's say, the client side cache? Can anybody answer that for us? When should you prefer the client side cache and when should you prefer the apps server cache? The answer, first of all, is that you always in big systems use every possible solution, right? So you use every possible solution. So you are going to do client side caching as well. You are mostly going to do caching inside, maybe at an app server or a global level. We are going to see what a global level caching is. So we are going to discuss everything. We are going to use CDNs as well. So, okay. So several of you have given me answers which are absolutely correct. The point is that if you store something on the client, now if you want to utilize while you are doing some computations, what would you do? So let's say you are doing your computations here, right? Computations are not going to happen over the client. Does it make sense? You are not going to run your systems, your models on the client. Does that make sense? People, does it make sense? And if the data that you require to make those computations fast, if the computations are happening here, the data would also be required here. Does it make sense? Storing that data over the client and then fetching that data in every request to do those computations. Does that make any sense? Does that make any sense? No, it makes zero sense. You would not want to store something far away if you have to use it right here, right? You would only want to store data, things at the client level cache, the things that you actually want to show to the client without the intervention of the server, right? The things that you want actually at the server, you would not be storing at the client. Does that make sense to everybody? Makes sense, Mohit. So you would not want to store essential information on the clients, confidential data on the clients. That's totally right. But that's not the only point, Mohit, if you understand that, right? That's not the only point. Even if the data was not confidential, you would not be going and storing that on the client because that is maybe not required there. That is required here. And why would you? The whole point of having caches is to reduce the time, reduce the latency, and you would not be actually transferring data between two different locations, right? One more thing also, the client memory is limited. You cannot actually store so much there. Okay, makes sense. Now let's actually take an example. Let's actually take an example and try to contrast between client server cache, client level caches and app server caches. Should we do that or is it clear? Can I move ahead or should I take one example so that the distinction between becomes more clear? Okay, let's take an example. So the example that we used, Abhi, was Tinder's example, right? We used the example of Tinder, right? The example was that what if you want to store your profile photos at your end? Or let's say the photos of your potential matches at your end. So maybe you can store that there. But let's say now, so what is Tinder, right? So let's say Lokesh goes to Tinder and he wants to actually, what does he want to fetch? He wants to fetch all the people that he can express his interest to, right? So he wants to get a list of prospective people, right? So the yeah, that's a good way to attract everybody's attention, Harshal, right? So now you get why I'm using this Tinder's example again and again. Okay, cool. So right. So yeah. So I was discussing that now the charter of the system is to figure out that what all options should I be showing to Lokesh, right? So now there will be some computation going on there. Now let's say, let's say this is a stateful system and Lokesh's data is residing over this box, let's say. So all the app, all the processing about Lokesh is happening on this box, let's say, right? right? So now, if I have shown to Lokesh some prospective matches before, let's say last week I gave him 100 prospective matches and he selected some of them. Some of the matches selected him as well, and they got a match and so on and so forth. But now, when the next week I want to process a new batch for Lokesh, is it necessary at my end to ensure that I do not send any repeated match? So let's say I sent a prospective thing to Lokesh and he accepted it, but unfortunately he was not accepted from the other end. Would I want to show that match again to Lokesh to make him feel bad? No, I would not want to do that. At the same time, if Lokesh told us that he is not interested in one prospective match, then should I actually keep on sharing that match again to him? No. And do you think this is a data that is required here? Or do you think I can store that data here as well? So let's compare and contrast both the options. So let's say I store the data at Lokesh's device that, hey man, I showed you these 100 profiles last week. And the next week, I again send a new set of 100 profiles. And now it's the client's due to do deduplication. Do you think it makes any sense for the client to do deduplication? No, because the problem would be that I would be sharing 100. First of all, his client would be taking a lot of time in doing the matching. And then let's say 90 of them happen to be duplicates. Then the client is only able to show Lokesh 10 matches, 10 prospective matches, and that will make him sad. You will have to make another request, get more data, and so on and so forth. So that is a very bad design. You would never want to store it here. You would want to store the data that what all prospective matches did I show to Lokesh on the app server where the processing is happening. Does that make sense? Does that make sense? And people, if this thing is clear to you, then trust me, everything in this system design is going to be very, very clear to you, because everything actually boils down to making a decision, right? Everything boils down to making a decision. If you understand the pros and cons of all the possibilities that you have, the decision that you are going to take, you are at least going to back that decision up, right? In several questions, there is no single correct answer in system design. So let's say when I take system design interviews, I do not look for a predefined single answer that I'm looking the interviewee to parrot. That's not what I'm looking for. Instead, what do we do is to say that, okay, if you are coming up with some design options, you should know that what all options did you have and what are the pros and cons of this design and how can you justify your choice, right? अब ऐसा नहीं होना चाहिए कि तुम कहो कि यार देखो just because like हाँ, so Sukanya, exactly my point. So whatever you say is not going to be correct still, because let's say I cannot go and say, hey man, I understand that I understand that the client would waste a lot of time in doing deduplication. I understand that Lokesh would be happy at only seeing 10 prospective matches, but still I feel that is the correct way to do. I understand all the cases, but still I feel that is the correct way to do because I do not want my app server to do that processing for me. Now you can very well say that that is okay. If that is what is very important to you, you can do that. But the interviewer will see that this guy is some kind of a weirdo and he or she does not appreciate the gravity of the situation enough, and that will also have you rejected. But unless and until you do that, everything else is totally fine. Cool. So we have discussed that. We have discussed client-side caching. We have discussed app server caching as well. We have taken some examples. Can we move ahead now? Okay. So I actually wanted to discuss one more thing of app server caches, and that was So that was primarily about right. That's it. So that was primarily about that. Okay, let's take a real life example at interview. Let's see what is the problem that we see with this, and that is a problem that we have already seen before. And let's look at another way of solving that problem. Okay, so let's take a real life example from interview bit. I will just tell you the sample problem, and now you guys will help me. I would unmute one of them, and one of you will help me to devise the entire plan of how to do it. Does that sound interesting? Please listen to the question carefully, and I would give chances to you guys to explain how you go about designing. So let's say, so you guys are using interview bit, and we have you submit your questions, your solutions to our DS algo problems, and we evaluate your responses and tell you whether your response is correct or you are getting a TLE, or let's say we tell you different points that you can have. Let's say 0 to maximum points that you can have. We do that. Okay. Voice is breaking. Is the voice breaking for everybody? And is it okay? It's fine, right? Okay, it's fine. Is it workable, or do you think it's a big issue? It's workable, right? Cool, 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 cool. So now, the problem is that you are going to actually submit your responses, submit your solutions, and you are going to get an answer. Okay. Now this is the problem that you are given. How would you design it? What computation would happen where? Do you need any caches? What kind of a cache would you require? How would the control flow look like? Who would want to take this up and discuss with the class? Let's take a minute's break. It's 10:52. I am going to ask you guys to volunteer yourselves at 10:53, and then we can discuss that. Is the question clear to everybody? We are taking interview bits example. You are given a problem. You want to submit a solution to it, and your solution has to be evaluated. So evaluate DS algo problem. Is the question clear? Okay. No, Sukanya. So we are not looking for the evaluation algorithm for the problem. We are not looking for that. I'm just looking from you to understand from a high level perspective that where will the computation happen? What kind of data would you require? Where will you store that data? Do you require any caches? What kind of a cache do you require? And so on and so forth. Is it a stateful system, a stateless system, and so on and so forth? Let's just wait for a bit more, and whenever somebody is ready, just let me know that you can volunteer. Okay, Chandan, we will be discussing that. Is that a question, Chandan, or is that a statement that you are making? Statement. Okay, okay. Okay, Sankalp. Okay. Makes sense. Sankalp, that's absolutely right. That's absolutely right. Think about it. I'm very happy with the way you are thinking about it. You have figured out a solution. You have figured out a possible issue, and let's try to find an answer to that as well. Very happy with the way you are thinking, Sankalp. Lokesh, you're absolutely right. But just try to understand, Lokesh, that does it make any sense to keep those things coupled? Lokesh, think about it. Does it make any sense to keep the two things that you are saying to be coupled? Or can those two things be decoupled? If those two things can be decoupled, try to understand the benefits of decoupling them, and then you will understand that maybe yes, decoupling them would be the way to go forward. Okay, Chandan. Lokesh, did you get that, what I just said? Okay. Yeah, think about it. Anybody would want to volunteer and maybe speak in front of the class and tell us? Um, Suganya, think about it. There are several flaws in the approach, but think about it. So, whatever decisions that you have taken, understand whether those decisions are actually required or not. Appreciate the pros and cons. So, let's say we want to use CDNs. So, you may not see any con of using CDNs, right? But there is a one very fundamental con that it costs money, right? If CDN is something which is not required, it costs money. Then that is something that you cannot. So let's say you are working at a big company and you say, देखो भाई मेरा काम है code करना, मैं तो भाई I will be using all the CDNs in the world, I will be using all the memory in the world. Money will be taken care by the finance team. That's not how things are going to. That's not the best developer that a company can hope for, right? And also, do not take anything personally. I'm just joking. I'm just randomly joking, right? So Aswar says we need to have a client. Yeah, just randomly joke. Need to have a client level cache to store the code. Hmm. Okay, okay, Aswar. Think about it, Uzair. Think about it. Is that really the case? Okay, okay, Bishari. Makes sense, Rishikesh. Makes sense, Nikhil. Makes think about it, Uzair. What you're saying, think about it. Okay, so would anybody want to volunteer? Sure. So Lokesh should want to volunteer. Let me unmute Lokesh. Hey Lokesh.
Hello.
Yeah,
Yeah, hi. Can you hear me?
yeah, we can hear you.
Yeah. So, according to my thinking, hello.
Yeah, yeah, please go on.
Yeah. So, as per my thinking, we can we can make a system like user can log in and submit
Of
his
course,
code.
so should I draw the basic outline, Lokesh? So there is a
Okay.
client,
Okay.
right?
Yeah. There is a client.
Always do this whenever you are solving any question, right? So whether there would be a load balancer.
Yeah.
We still don't know whether it would be using consistent hashing or not. So let's not write it right now. And then there would be some servers. Is that right? Or do you only want to use one server? That's the first
No,
question that you should ask yourself. Do you want only one server or do you want multiple servers?
multiple server will be better because
Okay, okay. So let's assume that you're going with multiple servers. And then maybe you want some storage servers as well. You want to store some data as well.
yeah.
You would want to store some data as well. Okay. And now there would be a DNS and there can be a CDN. If you want to use it, let me know. Now you tell me how would things happen.
Okay. There will be user will write some code on that editor.
Okay. There is an editor which is happening on the client side. Okay.
Yeah.
It is writing the
So
code on the client side.
okay. So I'm considering it is having rank and everything, scores and everything.
Okay. So for now, we can discuss rank scores as well, but for now, I would assume, let me tell you one very, very good way of doing system design. A very, very good way of doing system design is to think about in an as decoupled manner as possible. Do
Okay.
you think the rank list can be generated separately from submitting a question and getting a response? Do you guys,
Yeah.
does everybody in the class why, if I am asking you a question about solving the problem of figuring out a solution is correct or not, why would you want to bring in the why would you want to bring in ranking, right?
Voice is breaking. I mean,
Okay, okay,
I'm not able to hear you.
okay, okay. So won't be able to do anything. But the point is taking lectures from home and so actually I am living with my friend these days and the internet was very very poor there. I came at my place, the internet is uh, not very great here as well. Is the voice better now?
Yes, yes.
Okay, good. Yeah, okay. So do you understand that you would want to decouple the things? And let's not worry about the rank list for now. If you want to discuss rank list, we will discuss that later. But for now, think about you are writing a code and you want to get whether your solution is correct or not.
Okay. So in that case, I will write some code, and I can my code will be means whatever the calculation will happen, it should happen in app server, because code every time when the user will change the code, the output will differ.
Okay. Okay. So let's just, okay. That's a good point. So Lokesh is making the claim that the computation of the code, that is the evaluation of the code, should happen at the app server.
Yeah.
Is what you're saying.
Yeah, yeah.
Anybody in the class who feels that no, I would not want to do the computation on the app server, I would want to do the computation, the evaluation of the code somewhere else. Anybody in the team, anybody in the class feels that? I would want everybody to reply. Does everybody understand that it should be at the app server? Or does somebody think that maybe I can do it at the client? I can do it somewhere else? No. Can I do that on the CDN? Can I ask the CDN, hey man, can you do some computations for me? No. So never ever try to do any computations at the CDN. It's just a cache. You can just access data from there. You cannot do that anywhere else. App server is the best place where you would be doing your computation. Now, the question comes, Lokesh, when would you want to send that code to InterviewBit, right? So let's say I'm writing some code. I'm writing code, I'm writing, it has 30 minutes, I'm still writing the code. Should I make constant requests to InterviewBit so that
No,
InterviewBit
no, no,
store that code at their end? Or
no,
should it
no.
only be at the cache? Only be
I
at
will,
the client side?
I will save this data to client side. When the user will press Control S, I mean save tab, then it will save to the InterviewBit server.
Okay, so this is a perfectly good design. So you can actually design a editor which tells you beforehand कि भाई देखो, everything that you are writing is at your end only, but the moment you write Control S, I would take a snapshot of it and store it at my end. Okay, now this is one possible, everybody in the class, this is totally acceptable. But there can be some other guy who can say that no, yeah, I do not want that to be the case. I want my editor to be just like Google Drive. So if I write something at Google Drive, my laptop dies, I threw my laptop down my window and my laptop is no longer with me. But I wrote something important and I wanted Google Drive to save that for me. But I did not press Google Control S. I did that.
Then we have to
If
say,
you are building that kind of a then you will have to sync with your server overall, right? Then you cannot actually, you will have to make these calls again and again and actually sync that data to your server. Does that make sense to
yeah.
everybody?
So in
And
this,
both these solutions are totally correct. So Lokesh, if we want to actually only store it at client, that's totally fine. Go ahead, go on. When you
in the
actually press Control S or when you actually submit it, then you would make a call. This is what you're saying, right?
yeah,
Okay.
yeah.
So,
So if
so would there be two different kinds of calls? Let's say you are controls, so you are pressing Control S or you are pressing Submit. Does everybody in the class feel that we should only be having one call to the system for both these things, or do you think there should be different calls? What is call? Call is basically an API, API that you call over the internet, right? So there will be different
so
calls. Okay, does that make sense?
yeah, yeah, yeah,
So one kind,
different.
for now, let's only discuss about the call, which is the submit button, because save wala will deal with something else, and let's not discuss that right now. We can discuss that, but let's first of all again decouple the problem as much as possible, solve smaller and smaller chunks, and now the smallest chunk that we have to solve is when you press submit, then there will be a call which will be made to the load balancer of it. You will send all the code. And what else would you send? You would also send which user ID is sending that and so on and so forth, right? And now the load balancer receives that.
Yeah,
What should you do now?
it will assign a particular server, that app server, by by hashing.
Okay. Okay. So
And
you feel that this is a stateful request, and there should be a dedicated server which should be there to process requests that you are solving. How many
Yeah.
with that? Lokesh
It,
says, yeah,
if
yeah, please.
if you want just the output of this particular code, then it will become stateless.
Okay. Okay. So let me. Okay. So just because you have given both the answers, so let me just tell you how to think about it. Okay? Let me just tell you how to think about it. And everyone
Okay.
in the class, please take
Because it is
like I totally understand that. I'm not
your voice is again
pointing
breaking
any
down.
mistake on it. I'm just telling you that how to. Uh, is it better now?
Yeah, yeah.
Yeah, cool. So we were discussing that. So understand. Do you think that when you are evaluating the correctness of a code, do you
Yeah.
think it matters whether Aditya submitted that or Narayan submitted or Lokesh submitted that? Does that
No,
matter?
no, no.
It does not matter. Right? Was
Yeah.
getting the code and telling whether the code or not, it's totally a stateless thing to do. It does not matter. Okay, so guys, would you want me to end the lecture right now and discuss that tomorrow? Hello.
Hello.
Right. So yeah, I can actually disable my video. Maybe that will help.
Okay.
So is the voice better now?
Yeah, yeah.
Cool. So we were discussing that we were discussing that if you just get a code, right? If you just get a code and and you submit that code, getting the answer whether that's correct or wrong, totally just based on the code. So it's totally a statement, right? So and
Hmm.
also, what is the benefit of assuming it to be the benefit? Uh, so okay, so Lokesh, let me mute you as well. Let me mute you as well. Okay.
Yeah.
Okay. Thanks a lot. First of all, thanks a lot for volunteering, and I really appreciate that, and I really understood that you have understood the concept well, and that's great to know. That's great to know, Lokesh. Cool. Okay. Is the voice better now? Cool. Uh, okay. So we were saying that what are the benefits of making it stateless? The benefits of making it stateless is that now I can just, let's say, I can have a dedicated server. I can have a dedicated server only for doing this job. कि भाई the only job of that server is to check whether a code is correct or wrong. Is that a good design? That's a perfect design because now you can optimize your code based on the box's strength. So now you know that I have a box which has this much amount of memory. The only job that this box is doing is to check whether a code is correct or not. I know how to best utilize the memory. I know how to best utilize the disk. I know what to do. And that's a great thing to do, right? And also now you have decoupled one charter of your system totally with your remaining system. Vaishali is absolutely right. You can scale this. You can scale this very quickly. Okay. So you can say that today I am having a lot of rush because the lockdown is going on and everybody is there submitting codes and I want to evaluate their codes. Then I can spawn a lot more boxes for doing exactly this job. But if there is a day which is very hectic, let's say the lockdown just stopped right now and people have suddenly stopped submitting codes, then you can actually, you would see that you will auto descale your system and only have a couple of machines doing your job. Does that make sense? Does that make sense to everybody? Now Aswar has a question. Does it not include introduce a single point of failure? No, Aswar. I am not saying that you just have a single server to do all the to do every computer every evaluation in the world. I am saying that you have a dedicated set of servers for doing exactly this job. Does that make sense, Aswar? And you can scale them up, scale them down based on the specific requirement that you have. Does that make sense? It does, right? Cool. So now we appreciate that. And now we understood that making it stateless would be very great. Now, how to actually make a load balancer helping the stateless thing? So maybe you can just have a round robin algorithm. Does that make sense? Or maybe you can have a least computation time algorithm. With that, you would want to have a heartbeat mechanism. Does that make sense? Would you want to have a round robin with a heartbeat? Why heartbeat? Because you would want to understand whether which server is alive and which server is dead, and a round robin to make sure that you are spreading your load equally. Cool. So you have a round robin plus a heartbeat mechanism at the load balancer. You have these boxes, and now any code can go to any box. Now, to evaluate the code, do you require some data to evaluate the code? How do you actually evaluate the code? Yes, you require the test files. Does that make sense to everybody? You require the test files, right? If you actually require the test files persisted kahan pe honge? Where would be the test files persisted? The DB. Does that make sense? Test files would not be present anywhere else but in the storage layer. Is everybody in the class able to appreciate this? Right. So test files will be there in the storage layer. Now, if you do not have any cache, how will the thing look like? The thing will look like that you are submitting a code, the load balancer submits it to one of the servers, the server processes it, and the server is now going to process it, now going to fetch data from one of the DB, get the test cases, and then run the job and then reply back. Does that make sense? Does that make sense? The problem with that would be that it would be slow, right? You actually, every time you want to process a code, you actually going to the server, DB server, and fetching the test cases would be very slow. And in real circumstances, that would be very, very slow. Why? Because in real circumstances, you would see that a lot of different requests are coming for the same question. Do you guys appreciate that? If everybody in the world were solving one random question and there were no overlaps, then maybe having a cache would not help. People appreciate this very, very important point. If everybody in the world was solving a different question, then having a cache would not make much sense. But just because, let's say, people solve questions based on contests, there's a contest that is running, there are 10 questions that everybody is mad about solving, so it's better to actually cache the test cases of those 10 questions. Or let's say I am giving you an assignment today, let's cache test cases of those questions in the assignment. Okay, now the question that Lokesh is saying, it will become a stateful system now. Lokesh, that's totally wrong. Just because you are storing some data, will it become a stateful system? No, because it's still independent of who is sending that request. It's still independent at what time you are sending that request. You are just, so having that cache will only be saying, for solving this kind of a query, I require some data which I have stored at my end. Does that make sense, Lokesh? It does not make it a stateful system at all. I hope it makes sense to you, Lokesh. Okay. Bodhitavya says, all test cases can be stored at app server. They are text files. Okay. Okay. Bodhitva, I will reply to that. That's a good observation. But problem ID should be there in the request, right? Problem ID should be there in the request, Nikhil, for sure. But अगर आप कहना चाह रहे हो Nikhil कि in any stateless system there should be nothing in the request, that's not true, right? So let's say we discuss the example of a calculator. So at least 2 plus 3 would be in the calculator, right, Nikhil? It would not be that I will just send you a request and now you figure out what the request was about and you gave me the answer, right? Moise is absolutely right. Still agnostic to who is sending it, at what time is sending it, right? So it's still a stateless request. Cool. So now Sankalp says any EC2 instance it can go to. Okay. So what is the EC2 instance? How many of you understand what an EC2 instance? What an EC2 instance is? How many of you understand what an EC2 instance is? Okay. Some of you understand, some of you do not. Okay. So let's actually, in the next class, let's actually do one thing. I am going to maybe next class or maybe some class later, I am going to discuss a bit about AWS. Maybe take 5 minutes and discuss a bit about AWS and discuss about EC2, RDS, S3, and so on and so forth. Does that make sense? Cool. So maybe in some class, I will take 5 minutes to discuss that. So let's not discuss about EC2 at this point in time. Now let me see what are the other questions that I missed. No, we should use a blob store or dedicated file store system. Vishali, I did not get what you're saying. No, do you want me to unmute you? Vishali, do you want me to unmute you? Okay, sure. Hey, Beshali.
Hi. No, I was just saying that it's not a good idea to store text files in the database because DBs are not really optimized and file sizes can vary hugely.
You are absolutely right.
So we should use some
So,
sort of a file store system. So I would probably use a S3, but since we have not discussed that yet,
that makes sense.
I
So
was
let me,
just
let me
using a generic term.
let me just clarify that to everybody in the class what Beshali is just saying. First of all, both a DB or a file store will come in the storage layer. So till the time we were saying that I am going to store the data in the storage layer, nothing is wrong about that. Does that make sense? Vishali, do you also appreciate that? The file store, or let's say a DB, RDBMS, or let's say a NoSQL DB, all these things actually come in the storage layer. Okay? Now, what is the difference between a file store and a relational database? Do you guys know about relational databases? Like MySQL, the data is spread across tables. There are relations. Did I take your DBMS class? Did I take your DBMS class? No. Okay. Okay. So Nihal took it. So he would have explained that to you guys that how RDBMS are structured. It's basically a mathematical model. There are functions. You store data in tables and so on and so forth. Storing a storing a file which is a blob, storing a file which only has, let's say, data in it, does not have much relations in it, does not make any sense to store that in a relational database. Appreciate that. So let's say you just have a big image. Okay? Image is what? Image is just a sequence of pixels. Does that make sense? Is image just a sequence of pixels? Would you actually want to go and store an image in a DB table? No, you would not want to do that. Because anytime you are accessing an image, you are going to access the entire image at once. You want that entire file at once. You do not need to any relations in that. So you would actually be preferring storing that as a blob in a file storage. Okay. So file storage is a storage for things which do not have any relations amongst themselves. It's a file or a blob that you want to store together, a video, image, or in this case, a text file, a big text file which only has numbers and it only has test cases. Does that make sense? Would you only want to say that I want to access the line number 23 of this test file? You would not want to say that. You would either want to fetch the entire test file or not fetch the entire test file. Does it make sense to you guys? So storing these kind of things would be stored in a S3. What is a S3? Let's forget about it. Let's say a file store, or let's say a blob store. Does that make sense? Cool. Now, but still getting that blob, getting the test file. Okay, Sankalp is absolutely right. Sankalp is saying the path where exactly is this blob stored in the file storage. The path can be stored in RDBMS. How many of you appreciate that? There is a relation there. There is a request, there is a resource that you are requesting, and there is a location where that resource is. There is a relationship there. You can store that in RDBMS very nicely. Does that make sense? Cool. That's a great point that you raised, Sankalp. I almost skipped that. Thank you for raising that. Cool. So we have discussed that. And now one way would be that whenever a request comes, you will go to your file storage, get your data and process it and then respond back. But we discussed that that would be a poor thing to do. Hey, is my internet again unstable? Is my voice again breaking? Okay. Is it better now? Is it better now? Cool. So yeah. So as we just discussed that because the scenarios would be such that you are going to fetch the same blob again and again at the same time. So it's better that you can cache that at your app server. Does that make sense to everybody in the class? That we would want to cache that in our app server. Now, let's just keep one thing in mind. Keep one thing in mind that the time it takes to a cache versus a DB, it's generally 100 times. Okay. So if a cache takes 1 unit, making a DB call, fetching that data will take 100 units. Would you guys remember this for me? Cool. So just remember this for me. Okay. So you would understand that what is the difference between a cache and a DB. Cool. So you would, so in this case, DB call, or let's say a call from a blob storage, will most likely take you 500 milliseconds to 2 seconds. Is that a good design? So let's say I am writing a code I just submitted. Would you want me to wait for 2 seconds for you to get the test file, and then maybe 1 second to do the computation, and then maybe 200 milliseconds to me get the response back? And would that be fine? That would not be fine, right? So it's better that you actually use a cache there. Cache would actually most likely be using just like 10 milliseconds or something like that. And plus the evaluation time, which let's assume is 1 second, and you can get the answer. Cool. So now we realize that there is a cache that should be there on the app server. Now, if a cache is there on every app server, do you understand that there is a data that is being duplicated? Do you understand that there is a data which was essentially present in the blob storage, but if there are 5 instances running at the moment for doing my evaluation, now I have 5 copies of that data. Does that make sense? Okay. Now, these 5 copies may not be exact replicas of each other. May not be exact replicas of each other. Appreciate that. Why they may not be exact replicas? Let's say every box has a LRU of its own. And in actual cases, because every request is coming randomly, these caches should be very identical to each other. Because the kind of questions that are coming on, let's say, box 1 should also be the kind of questions that are coming on box 2. The distribution should be almost equal. But still you cannot say that the cache would exactly be the same. Does it make sense to you guys? Does it make sense? Cool, it makes sense. Now, let's do just one more thing. Let's say that this actually helps me. Now I can make my system a bit stateful and do something better. See why I am discussing all these things. I understand that maybe discussing a lot more things may confuse you guys, but if you are able to appreciate what I am discussing, then let's actually go in every direction and see what all we can do. Because system design is all about that, right? So if anybody is feeling left out, please let me know, because otherwise I will be assuming that you guys are with me and I will be discussing whatever direction my brain is taking me to. So is everybody with me? Yes, cool. So now let's say that I can make it a bit stateful, and let's say I am CodeChef. Okay, I have the responsibility of running ACM ICPC. Okay, now when ACM ICPC is running, let's say a normal college contest is also running. Did my voice break in between? Are you guys able to hear me? Okay, Sankalp, I will repeat it. The point is, let's say I am CodeChef. I am running ACM ICPC today. Okay, I am, let's say, running Chennai regionals today. Okay, and some other random college contest is also going on my platform. Would you now want me to prioritize the solutions for ACM ICPC? Would you want me to do that? Or would you want me to say, nahi, everything is at the same level, and even if you are actually from a random college contest, that is also equally important for me. That's not equally important for me. So what I can do, I can actually have a different, I can now make it slightly, I can now tell my load balancer that if you have these kind of requests, then send to this group of servers. If you have any other request, send to these group of servers. Does it make some sense? And now you would appreciate that having a different cache in different boxes makes total sense, because some of the boxes will be having the caches for the ACM ICPC questions. Some other boxes will be having caches for some other questions. Does that make sense? Now let me, at the same time, though this is totally doable, this is still maybe not the thing that CodeChef would be doing. Exactly, Vaishali. You are absolutely right. Exactly what I was about to come to. This is may not be the exact thing that CodeChef would be doing. Should I tell you that right now, what CodeChef would be doing mostly? The CodeChef would mostly be using a queue. Okay. What is a distributed queue? A queue is just like, yes, I am sharing the screen, but I'm not writing anything there. Okay, let me just a minute. So what most likely CodeChef would be doing is the load balancer or in fact we at interview would also do, the load balancer is going to insert all the requests that are coming to a common distributed queue. Does it make sense? To a common queue. Every request is there in the queue. Now there are so many consumers of that queue. So all the app servers that I have are now consumers of the queue. So let's say there is a queue in which you are sending all the requests that are coming. And now there are so many app servers here. All of them are called consumers of the queue, and all of them are one by one polling one question, one submission from the queue, evaluating it and removing it from the queue. Does it make sense? Yes. So this is what a messaging queue is. These are basically messaging queues. We are going to discuss messaging queues in greater details going forward. But do you get the basic idea here? Do you get the basic idea here? So let's say there is a there is a gateway box here. Okay. So now somebody asked me a question. Will the load balancer be the one who is producing the request, or would it be a normal app server? So that would be a server, but you cannot call it a, you would not want to call it a load balancer now because it's not balancing any load. Does it make sense? Now it's just a server who is just passing the request to a queue. Does it make sense? You can still call it a load balancer. I would not be very unhappy with that. But at the same time, try to appreciate that this no longer is balancing any load, right? It is just forwarding every request to a queue. And now you have consumers. So this happens to be the producer of my queue. So let's not call it now. These happens to be the consumers of my queue. They will keep on getting one element at a time, process it, remove it from the queue, and move ahead. Now this queue can also be made a priority queue. What is a priority queue? Priority queue is a queue in which you can actually assign different priorities. So let's say I can assign more priority to submissions of ACM ICPC, and I can say just because Vaishali is laughing or smiling, I would want to deprioritize her submissions just because I feel like doing that. Of course, I do not feel like doing that. That's just a random joke because the class stretched a bit too much. Cool. So, so we would, okay. So now you can prioritize things, you can deprioritize things. And how to actually do that, we will be discussing that when we discuss messaging queues, but you appreciate that this can be done logically. Does it make sense? So Sukanya is saying that queues are after load balancer. So queues are not after load balancer, Sukanya. Let's just call this a gateway server. Let's just call it a gateway server where all the requests are coming and I'm inserting those requests in the queue. Right? That's it. Okay. Cool. So we appreciate this now. But one distinction between the two options that we had, one thing that if we have an app server based mechanism, make it stateful, then you can actually have different caches at different boxes. But if you do not have if you have equivalent consumers for all the requests, then cache misses will happen a lot more. Does that make sense? Does that make sense? If you have the same cache everywhere, then cache misses will happen a lot more. What is a cache miss? Does everybody in the class understand what is a cache miss? Cache is a small amount of memory that you have. Cache misses that you are trying to see whether a particular key value pair is available in your cache or not. And if you realize that that key value pair is present, then you call it a cache hit. You will just take it up from the cache and do your computation. If you see that that key value pair that you're looking is not in the queue, you will not in the cache, you will call it a cache miss. And maybe now you will actually go to the storage layer and get your data back. Does that make sense to everybody? Does that make sense to everybody? One doubt still left. Okay. So Nikhil has a doubt. One question in app server, cache will be storing test file URLs or test files itself. Okay. So everybody please answer this for me. So there is a doubt from somebody who is saying that the caches at these boxes, would those be storing the test files themselves, or would those be only storing a link of the test files and the test files would still be at some other place? So you guys tell me, what would the cache would be storing? it would be storing the test file, right? Because if it is still storing a link, then nothing changed. Then why are you having a cache also, right? So try to understand. So you all you already knew that there is a box where I have that thing stored. Now just again creating another copy of that does not make much sense, right? You would now want to store the entire file there. I hope it makes sense. Let me see what other questions are there. Uday says, so what happens if I'm solving some X problem on scalar, from where it fetches the test cases for that problem, it will fetch from the DB or from the app server. So Uday, if you're solving a problem, it will first check in the app server's cache whether the test cases of that file is available or not. If they are available, it will just utilize it from there, do the computation, return back. If it is not present there, if it happens a cache miss, it will actually go to the DB or the file storage, get the test cases and do the computation and then reply back. Will make complete sense. Now there is, Deepika says repeat last part. Deepika, what part do you want me to repeat? Or is that a is that a previous thing that you, okay, that's that, cool. One doubt from Archit. So after response from load balancer, it's important that it will reflect most of the client pages and how it is totally stateless. Understand analysis code is stateless, but it is important which you will. Okay. So Archit, I'm not saying that the entire system is stateless. I'm not saying that the entire system is stateless. I'm saying that this particular API that you will be building would be stateless. Does that make sense to you, Archit? That building an API which will just take in a code and tell you whether that's correct or not, do you think that should be a stateless? That can be stateless? Yes, no? Archit? I hope it makes sense to you, Archit. Waiting for you to reply. So yeah. So the API, so it's the API called from app server. No, so the API will be called by the client. The API will be called by the client. The URL of the API would be that of the load balancer. The load balancer will figure out what kind of a request that is. It will then forward it to the correct set of boxes or box, let's say to a gateway, and it will then maybe send to the queue. And then there are app servers who are reading from the queue and solving it for you. Does it make sense? Okay. So Vaishali says, in general, if the resource is static, I tend to think of a CDN. But here we would store the test files at app server cache. Would keep a global cache for all the app servers? Then all app servers can benefit from having the recently used test cases available in the global cache instead of maintaining it locally. Vaishali, that's a very good point. Let's just wait before I discuss global caches. I have not discussed global caches for now. Let's just wait. Okay. So, but one thing that you would understand. Okay. So now, Vaishali, one thing that you said did not make me very happy. So you said that whenever you look at static resources, you always think about CDNs. So you should add one thing there. Whenever you look at a resource which is very, very widely usable to for so many people in the world, then you think about CDNs, right? And also the resources should be heavy. Manish is absolutely right. The resources should be time critical. That's again the point. And then the resource should be such that it is being used by multiple people and the resource can directly be utilized at the client. That is the biggest point. What if the resource is required at the app server? Would you want to store it at the CDN? Of course not. CDN is sitting next to the client. Here I want the test files with me at the app server. Would I want to store my test files at the CDN? No. Consumer, मतलब यूजर क्या करेगा भाई मेरी टेस्ट फाइल से कुछ नहीं कर पाएगा और देनी भी नहीं है वो, वरना क्या करेगा इफ एल्स लिख देगा पूरे कोर्स में और सबमिट कर देगा, राइट? तो उसको देनी भी नहीं है टेस्ट फाइल्स. So storing the test files at CDN does not make any sense at all, right? So let me now look at some other questions that we have. Somebody saying, can you copy paste the Vaishali's question in the group? I can do that. So let me just, so this is the question that Vaishali asked. Cool. So now let's say what all questions are remaining. Sankalp says, in case that's a good question, Sankalp. I will be discussing that. Wait for a while. I will be discussing that. That's a very good question, and that I will end my class there after discussing that. So now Narayan says high priority request will go to a specific app server. So Narayan, that is one possible approach. that you can actually say that the high priority things will go to one app server, one group of app servers, low priority things will go to some other group of app servers. But that is not the only approach. We just discussed the approach where you can actually have all the consumers at the same level and doing everything at the same level. Okay, cool. Now, what else? Sankal is saying, Sankal, I will answer that question. Deepika says, if few APIs are stateless, others are stateful, then need to design should be stateful or okay, makes sense. So Deepika, we can actually define our stateful or stateless things as APIs only. You need not call the entire system as stateful or stateless if it's not following one single pattern. Does that make sense, Deepika? In fact, in today's real world, you would not find any system which is purely stateless. Do you appreciate that? Because everybody is running after money and data is money. Unless and until you ask your consumers to create accounts and store your data with you, you cannot make any money. Does that make sense, Deepika? So system in today's world can be totally stateless because you would want them at least to register on your service, right? So that's why your thing could be a combination of stateful and stateless applications. Your thing can only be stateful. All the APIs can be stateful. But the point would be that if all the APIs are stateful, then you miss out on some leverages that you have using stateless APIs. You understand that, Deepika, right? Whenever your API can be made stateless, it should be made stateless because now you can do much better distribution of load. Does that make sense? Okay. Now, Deepika says, so but the consistent hashing would still be required for stateful systems, for stateful APIs. That makes total sense. So Deepika's question, everybody, is that there are some APIs which are stateful, some APIs which are stateless. For stateful APIs, I would be using consistent hashing. For stateless, I could be doing round robin. So how can do I actually have different load balancers? No, you need not have actually different load balancers. The load balancer can be intelligent enough to figure out that this is one kind of a request. This is one API call. This API call should be distributed using consistent hashing for these servers. This API should be solved using round robin for this server. Does that make sense, Deepika? You can have different for different things. Now, do you call it different gateways? You can call it different gateways, but gateways are logical concepts. So you need not have a physical box to segregate different kind of requests. So actually you do not have different boxes. You have a simple box only. Different microservices. Okay. So basically microservices are not exactly same as simple APIs. Microservices are without a doubt APIs, but microservices means that you have divided any particular application into the smallest possible logical entities. Okay. And now those logical entities communicate amongst themselves to give you the total answer. The other option of microservices, if you do not want to use a microservice, then it's called a monolithic or a monolith. What is a monolith? A monolith is a single piece of code that you write in which you have a complete control flow. Let me just write that. So we have discussed things today. So let's say a monolith versus a microservice. So monolith is that you have a single piece of code that is running, which is doing all the job for you. So let me tell you one example that I myself changed from a monolith to some microservices and remaining thing as a monolith. So I was working at Media.NET Direct Time. The charter there was to actually build systems in which you're going to look at a URL and figure out what is the most appropriate advertisement to be shown on that URL. Does that make sense? The charter of the system that we are building, given a URL, any URL, and figure out what are the best ads that you should show so that you make the most money. Now, at the beginning, when we built the system, we built it as a monolith, right? So we had one big Java module, and we exposed an API that was still an API. So, right? So some other team would be calling my API and I would be doing some processing in a monolith. So in a single piece of code, I will be doing all the processing and my API will give you the response, or maybe I will not give the response back to you, but I will store some response in some DB and you can fetch that response from that DB later, right? So when you send me a request, I will just tell you, hey man, I received your request. Let me take some time क्योंकि I am slow, I will be running some ML algorithms at the back end. I am slow man, I cannot give you the response right away. So I have taken your request, but I will send that request to a DB and you can look it up from there. This is a monolith. Now to convert that as a sequence of microservices, what did we do? We actually built different APIs for different small components of our job. So let's say whenever I get a URL, the first logical thing that I did was to actually figure out the content of that URL. Does that make sense? So what did I do? So when I actually started making it as microservices, the first microservices service that I built was to figure out the content of the page. Does that make sense? Okay, so the screen is not getting shared, right? Let me just share it again. Is the screen being shared now? Do you guys see the screen now? Cool, thank you. So, sorry. So let's just come here. So the first would be a microservice to get the content. Once I get the content, then there would be a microservice which would be parsing that content. So I got the raw content. Now I need to figure out that what all things are important for me. Then maybe based on that, I would have a cleaning API, a cleaning microservice. That is the content I've got. Now I need to clean that content. Now I need to actually have a categorization API where a machine learning model runs, which will categorize, figure out the category of that URL and tell you the category of that URL, and so on and so forth. Does it make sense, Vaishali and everybody else in the class? This is what is called as microservice-based architecture. You can have a same thing as a monolith as well. Everything will be running using APIs only. This will also be running using APIs. This will also be running using APIs. Does it make sense to everybody? Now, what is the benefit of monolith versus microservice? Let's not discuss that today. I see very few people in the class today. Remind me some other day and we can actually discuss what are the benefits, pros and cons of microservices and monoliths. Sankalp, you're right. Okay. So would you guys remind me on some other class to discuss this? Because this is an interesting concept. I am pretty sure that I think that you guys should know it. So let's just remind it and discuss that in some other. Yes, 100% asked in many interviews. Let's just discuss that in some other class. Cool. So we have discussed that. Okay. We discussed that we can actually store our test files in our caches at the app servers and do our processing. Now, there is one big problem with it. And some of you already pointed that out. If I'm not wrong, Sankalp definitely pointed that out. And the problem here again is of cache invalidation. Does that make sense? So let's say there is a problem ID 107. That problem ID has, let's say, some test file IDs. Let's say there is a test file ID 9711, test file ID 712, again for the same problem ID. So let's say this problem ID has 3 test files. Does that make sense? This problem ID has 3 test files. Now, what happens? Let's say I have synced all these test files in all the app server caches. Does it make sense? Let's say I have 5 instances running and every instance now has a copy of these 3 files. People, are you with me? And let's say tomorrow Sankalp comes and tells me that, man, you made a mistake in one of your test files. The test file 524 that you have has a mistake. So now what I will have to do, I will check it and I will say that, yes, Sankalp, you are right. This file had a mistake. And now what will I have to do? I will have to make sure that every app server now has the updated copy of this test file. Does that make sense? Does that make sense, people? Do not ensure that what will happen? Now several other submissions will be processed by wrong test files, right? So let's say this instance was updated. Let's say this instance got updated. So let's say I sent an update request to all of them. This got updated, this got updated. Let's say इधर ये network में फंस गया, जाम मिल गया इसको यहाँ पर और ये network में फंस गया update नहीं हो पा रहा. अब all the requests that are actually coming to this point will actually be doing dirty reads, as Vaishali points out. So now you will be doing, you are now out of consistency. Does that make sense? You are no longer consistent. Does that make sense? Right. So you are no longer consistent. You are now doing a dirty read, and you will still be giving wrong responses based on these new requests. And now the problem will become very difficult, because before Lokesh or whosoever pointed out the problem in 524, I could have done one thing. I could have said, "ठीक है यार, I updated my mistake at 5:20 p.m. today, and whatever things were processed before 5:20 p.m., I will reevaluate them." Does that make sense? But now, just because now I have another variable, which is I do not know when was my cache file updated at what location. Now, can I actually use this 5:20 p.m. as a sacrosanct time? I cannot do that, right? Because there will be some servers for where the files were updated at 6:20 p.m. or 6:30 p.m. For this 1 hour or 1.5 hours, they would still be showing wrong requests. Does that make sense to everybody? Does that make sense to everybody? So it is very important that you would not want this to get out of your hands, and there should be some way of making cache invalidations. Is everybody in the class with me? Right. So now, one way to solve this problem, which Vaishali rightly pointed out, is the fourth mechanism that we wanted to discuss in the caching class. And with that, we will be ending our class. The fourth mechanism that we have is essentially called as a global cache. So what all caches did we discuss till this point in time? We discussed client-side cache, we discussed CDN, then we discussed app server cache, and now we are discussing a global cache. So what is a global cache? A global cache, let's build the diagram again. You have the client, you have the DNS, you have the CDN, you have the load balancer here, you have app servers here, and then you have the storage layer here. So this is storage, this is app server. So one thing, so no matter whatever you learn from these classes or not, one thing that I'm sure that you would learn is this diagram. Is that right? Would you at least draw this diagram in any interview that you give? At least draw this diagram, right? If you do not draw this diagram, that would be a very, very sad thing to do, right? So at least remember this out of the classes. Okay, cool. So now, rather than having an app server cache, we can actually have a global cache, which will be a different box, or let's call it a server, a different server, or a group of servers, right? It may not be a single server, it can actually be a group of servers. This is a cache which is now being decoupled from the app servers. Does it make sense? Does it make sense, people? So this is called as a global cache. So each of these app servers are going to fetch data from the same global cache. Does it make sense? Does it make sense? Okay. So now there are so many pros and cons of global cache versus app level cache. And we are going to discuss that as we go along as our classes. Let me discuss a few things of why global caches may be better in some ways. One first way would be that I would say that now you can actually, you are not duplicating data. You are not duplicating data. Does that make sense? Will this be true in every scenario? No. This will be true only in the scenario where every app server is doing the same kind of things. If every app server are doing different kind of things, would this global cache help us? No, because every one of them would require different set of data. Does it make sense to everybody? Does it make sense to everybody? Right? So some of them can use, some of them cannot. Let's not make a sweeping statement that every stateless can use it, because some stateless may not be also able to use it, but we would not have some rules in our mind. Instead, we would keep our mind open and look at every problem on its face value and do the decisions. Okay? Let's not set some predefined rules. Let's not make sweeping statements. Okay, cool. So one is you are not duplicating data anymore. Second advantage of a global cache, I would say, is that it's relatively easier to invalidate. Does it make sense? Because you now have a single cache and you are not spread across multiple boxes. And of course, you can still be spread across multiple boxes, but at least you have one point where you can communicate to rather than communicating with so many different boxes. Does that make sense? Do not misassume this statement to be that we have a single box now. Does that make sense, everybody? Do not misassume. This can still be consisting of multiple boxes, but you now at least have one single point of contact. People, does it make sense? Right. This is distributed cache. Now let's come to the third thing. Or maybe if that does not make sense, you can remove this point, right? Because that's not a very, very big point anyway. Now let's come to the third point. That would be very interesting, and that would be that you don't have big उसको क्या बोलते हैं, कौन सा पीरियड बोलते हैं यार उसको, what is that period called? Boot up time. What is that period called? That you are bootstrapping something and you do not have any data and you are filling your caches. So what is that period called? I remember that from college. That's a great term. I am not able to recall it. So that's called as not the bootstrap time, not the boot up time. That is called as the I will recall it and put the correct name here. But we do not have big for now. Let's call boot up time, but that is not the correct term. So we do not have big boot up time on new spawned servers. Does that make sense? So let's say a new server is spawned. Okay, if a new server is spawned, do you appreciate that if we were using app servers, then the server's cache will be empty? Does that make sense? If you are using app servers, the server's cache will be empty. But if you are using a distributed system, distributed cache, a global cache, then the moment a server is spawned up, the boot up time of the cache would be very less. Does that make sense? But then there is a big flaw as well. What if your distributed cache goes down? Now none of the boxes have any cache left. Does it make sense? So these kind of things, I need not write all of them. You would be able to figure out yourself. Does that make sense, people? Trade-off is the key to system design interviews without a doubt. Trade-offs is exactly what any system design interviews would be based upon. And that's why it's very, very important to understand the concepts very well. And that is the reason why I told you, do not go with other resources for now. Understand the classes properly and only then go to other resources. Because misassuming things is the worst thing that you can do. Cool. So we've discussed this. Now, okay. Doesn't this contribute to another hop just like a storage system? Makes sense, Aswar. This would contribute to another hop. But understand that the place where this is stored is actually a RAM, right? Or a SSD. So the access time would be very quick. And also, you would want to store this nearer to your app servers. So the network time should also be low. But yes, it makes total sense that now you have introduced one more hop and you are not only getting the data from the exact same system itself. Does it make sense as well? Cool. Cool. Now let's look at the problem that we had. The problem that we had was that I want my app servers to compute the evaluation for any code, and all of them have their own caches. And what if I have a problem, let's say 107 problem ID, I have the test file ID, which can be 7119125025007. Now let's say 507 file got updated. I will have to update in all of them. This was the problem of cache invalidation. One way to slightly solve it would be to have a global cache. The problem of cache invalidation will still be there, but so let's not just call it. Okay, let's not just call that a way out. Let me tell you what we at InterviewBit are using to solve this problem. So that would be the fourth way of doing cache invalidation. Does that make sense, people? Does that make sense? Okay. So what we do, we call that strategy as indexing. So what is indexing? as Beshali and somebody else told to the class already, that in the storage layer, the test files are actually stored in file storage. Does that make sense? Or we call it blob storage. But what do we do? And Sankalp told us that we can actually have in a RDBMS, we can have a table which will tell me the ID of the resource and the link. Does it make sense? What we also do in our interview bits case is have another table in the RDBMS which will ideally have a mapping of a problem ID to the name of the test file. Does that make sense? So, okay, let me just explain that properly. So, what we do at interview bit, we have a table in the RDBMS. What is that table? That table's first column is problem ID. That for this problem ID, for this test case ID, so let's say problem ID 507, test case ID 102, 103, for the same problem, another test case 711. Does it make sense, guys? Does it make sense? And let's say for a different problem, let's call it 1011 or something, and some test case 172, and so on and so forth. Now, apart from this, we also have a file name column. What is the file name? The file name is basically the name of the test file. Does it make sense? Name of the test file. So the naming convention that we follow for the test file is this: problem ID underscore test case ID underscore timestamp when it was last updated .txt. So let's say this 711 file was originally something like 507 underscore 711 underscore, let's say 24th May 2019 .txt. So the entry originally was this. Now what happened? Sankalp came in between. He told us that the test case ID 711 is wrong. So what did we do? We were slightly sad. And what did we do? We updated it. And once we updated it, the entry there was also updated. A new file was created with the name 507711. Let's say today's date is 1st April 2020.txt. I create a new file. I store this new file in the blob, in the storage. Let's call it file storage or blob storage. And at the same time, in this DB, I updated the value of the file name. Does it make sense, people? Does it make sense? Now what will happen? When a new person comes, when a new request comes, after Sankalp has told us the files are bad, a new request comes. The request will go to the box. The box will check its app server cache. It will see that for this request, because the request was for problem ID 507, it will check that I have these files with me: 507, 711, 24 May 2019. I also have a file 507, 103, something else, 24 May 2019. I also have file 507, 102, 507. Yeah, that would be a timestamp, Sankalp. I'm just writing the date, but that would be a timestamp, right? So I would have another file 507, 102, and let's say this was last updated at 16th December 2019, 5:20 p.m. Okay. Now what will happen? The moment you see that these are the files that I have, my box will also make a call to RDBMS and say कि भाई 50 के लिए जो भी entries है दे दो. The entries that the box will get from RDBMS will look something like this: 507, 711, 1st April 2020. And I will see that this file I do not have. Does that make sense? Everybody in the class? I will realize that this file is not there with me, and I will not use the bad file and instead make a call to the storage, get the correct file, and then solve it. Does it make crystal clear sense to everybody in the class? If there is any doubt, I will be more than happy to answer. So what will happen? The exact test files that have changed, only those will stop matching with the name that you got from the RDBMS and the file name that you have. Everything else will match, and those files you will just get again from the storage. Does it make sense? Yes, seems similar to hash approach. Everything boils down to the same thing only, but there are different ways of doing it. So for every request, you are going to do a DB access as also. Exactly. So you're going to do a RDBMS access in every request, but that would be a very, very small thing because a very, very small amount of data is being transferred. Does it make sense? So why are we storing old files in cache? So Archit, we stored the old file in cache when that file made sense. So we never knew that Sankalp will come out tomorrow and tell us that, hey man, stop using this file. We did not know that, right? So we were storing that previous file because we were assuming that to be correct. Now Sankalp came in, he told us that the file was bad. We now have got the new file also. And let's say there is a cron running which runs every time at 12 AM at night. And what does it do? It says that tell me all the files for 507711. And let's say it got 3 files, 1, 2, 3. It will only keep the latest and will delete the previous ones. Does that make sense? And that will allow me to empty my cache as well. I can just have a cron. Does that make sense to everybody? Does that make sense to everybody? How to design big scalable systems, think about everything that comes into place, how to utilize our knowledge and to build it. Right? Makes sense. So yeah, we can end the lecture now. I am happy that 37 of you stayed back with me. And for everybody, I would request, we have covered so many things in the class. Please make sure that you revisit the lecture. Tomorrow, I will be discussing a bit about cache replacement strategies. Okay. And then we will maybe take up a problem and solve it. So Bhanupal says when you update the DP, update the cache at that time only. Okay, Bhanupal. So Bhanupal, if you update the DB and update the cache at that point in time only, first thing that maybe that server is not solving for that request at this point in time. Maybe Sankalp is a weirdo. He solved a problem that nobody is solving these days. And he told us that the test files are bad. Would I actually want to store the updated test file in every system? No, because nobody is solving it, right? But yes, if people start solving it, I will want to have it there. And also, just because I told you already, just because you have to update these things at so many different places, there is bound to be a delay, and to handle that delay is what we came up with this idea of indexing. Does that make sense? Does that make sense? Now there is a question from Abhishek. Requesting a DB access every time beats the purpose of caching. No, it does not, Abhishek. You are caching the file. The file is very big. You are saving the time of transferring a very, very big file so many number of times. Now you are just going to a RDBMS and getting a very, very small piece of data, which is just a row with 3 numbers. Does that make sense, Abhishek and everybody else in the class? Why it's not the same thing? Okay, waiting for you guys to reply. Now we have a question from Archit. Can we discuss one use case of Flipkart? Okay, so Archit, how I will go about things is I will look at the things that we already discussed, and based on those knowledge, whatever system I feel we can design, I will pick that up. But at the end, when we have discussed everything, you can come up to me, tell me why would you want to discuss any particular thing, and we can discuss that. That's totally fine. Okay, cool. Is need to find where to update. Narayan, do you have a question still? Do you want me to unmute you, Narayan? I'm not able to understand your question. No, you got it right? Okay, cool. So now we have Sohail. Is message queue a part of load balancer? No, Sohail. Message queues are totally different concept. Message queue is a concept in which you try to decouple. So what is a message queue? Should I do it in the next class? Should I not do it right now? Because then people would miss out on it. Okay. So message queue is not a part of load balancer. We can discuss message queue sometime later. So we are updating cache after finding a mismatch. You're absolutely right, Sukanya. Uzair says that I have one doubt. When cron run takes place, it finds out 3 original files and once they added, motto is to remove the defected file. But we are removing the on the last. Okay, Uzair, I did not get your question. I will unmute you. Do I unmute you, Uzair? Should I unmute you? Cool. Yes, it's too late, and thanks for staying back, and also understand that it's not very easy for me also to stay back. I also have to go back to my friend's place. But yes, I thought that yes, if there are some things that we are discussing in one coherent fashion, we should discuss that. Yeah, Uzair, please tell me what's your question. Uzair, I have unmuted you, but I can't hear you. Sankalp, we will try to cover Kafka. We will try to cover Kafka. Uzair, you are not audible. Let's actually discuss that question tomorrow. Is that fine, Uzair? Cool. Okay. I am also hungry. Cool. So yeah, let's end the class now. Thanks a lot for attending the class. I hope you guys enjoyed it, and please also tell your friends to come to the classes, start attending classes. I'm not very happy with the amount of attendance that I'm seeing, but yeah, cool. So all the best, everybody. And yeah, I really enjoyed teaching the class. Yes, Uzair. So my health was slightly better today, so maybe that's why you enjoyed the class maybe better today. Cool. So yeah, everybody, thanks a lot, everyone. Hope to see you again tomorrow or day after. And please make sure that you revisit the lectures, because if you do not, there are so many things that we discussed, you are bound to miss out on things, right? If you do not revise the lectures, you are bound to miss out on things. Make sure that you revisit the lectures. Okay. Yeah. Thanks a lot, everybody. See you again. Bye. Good night.